I remember my wife had sort of long experience. She said all the time, listen, I don't when she just begins to move into the middle, you know, particularly what a big thing, and sort of counselling beforehand. And I knew when she was back on the recent I saw Diana, and I used to wear, she was round the corner. I thought it was really good. Yeah, I thought that she decided to actually never stop whistling. I think it's time to get
Ladies and gentlemen, good morning. It is now 9:26, and so by parliamentary standards, an event scheduled for 9:15 is probably about ready to begin. We are a small but distinguished number, but of course we are also web streamed, so what we have to say is available to the world as a whole. As many of you will know, I am Roger Helmer. I am a British member of the European Parliament. I'm a member of the UKIP party. I'm also our spokesman on energy and industry. I personally have been taking a great interest in questions of climate and energy for at least 10 years. I think it was 2008 when I conducted a first conference on these subjects in the European Parliament. How did I come by it? Well, I didn't, when I was elected, have any particular interest in climate and energy. I think we have to thank Mr. Michael Mann, who, of course, as we all know, is the creator of the famous, or should I say infamous, hockey stick graph. And when I first saw that, that was really my first engagement with the whole issue of climate. And if you merely look at the hockey stick graph and you know nothing else about it, and it's come from a scientist, so of course it must be right, then I was quite alarmed. I thought, here is an issue, here is a matter for concern. So I started looking at it and studying it and reading material from various sources. And of course, following the story as the whole hockey stick graph started to unravel, and I gradually became convinced that the orthodox position, if I may so describe it, that is the United Nations position, simply could not be sustained through scientific evidence. If you go back to the first IPCC report, which was a major piece of work, there was a very good graph in there showing temperature over the last 1,000 years. And two things struck me about that. First was that the temperature as recorded in that graph today was lower than it had been in the medieval warm period. And since then, of course, I've studied it further and seen that the same applies to the Roman optimum and the Minoan optimum and the previous optima during the current interglacial period. So we don't have an exceptional heating of the world that needs some special explanation. Also, I was struck by the fact that the global warming that we heard so much about was actually rather small. And if you take the global warming over the last 100 years, if you go and ask a person in the street, they'll say, well, it's a major problem. What is it, 5 degrees, 10 degrees? I don't know. Actually, the figure is around 0.7, 0.8 degrees centigrade, which represents, in a century, the same sort of rise that led into previous climate optima. Other points actually struck me forcibly as well. I got as far as learning that the climate sensitivity of CO2, atmospheric CO2 was governed by a negative logarithmic equation. In other words, the more CO2 you have in the atmosphere, the less effect it has, which struck me as being a very important conclusion. Another very striking fact that emerged from a reading of the literature was that if you take climate forecasts, computer forecasts of climate from 10 years ago, 15 years ago, and you compare those forecasts with the actual temperature over the period, it is true to say that virtually every published computer forecast of temperature has actually exaggerated the real figure. And indeed, as we know, for the last nearly 20 years, there's been very little further global warming at all. The conclusion that I reached was that we have a well-established long-term pattern of climate fluctuation with cool periods followed by warm periods. And it seemed to me the most likely explanation for changes in temperature over the last 200 or 300 years was simply a continuation of a well-established cyclical pattern. I don't think there's 100% agreement as to what causes that cycle over roughly a 1,000-year period, but it seems most likely to be an astronomical phenomenon, not actually an anthropogenic phenomenon. And I believe, in fact, that the carbon dioxide ice caps on the planet Mars follow roughly a similar pattern. And as far as I know, there are no 4x4s being driven around by Martians generating CO2 in that atmosphere. So I became convinced, in fact, that the orthodox position is wrong, and therefore that the solutions proposed of reducing CO2 emissions drastically would, first of all, not actually achieve the result desired, and secondly, they would have a disastrous impact on our economies. And we are now seeing that. My particular concern as a European Member of Parliament is that Europe's economy is being very severely damaged. I would quote Antonio Tajani, who, as you will all know, is now the new president of our Parliament. Some years ago, when he was the Industry Commissioner, he actually said that energy prices were creating an industrial massacre in Europe. I have quoted that line again and again, but I think it is worth quoting one more time, particularly in a circumstance where we have America, which is pursuing industrial regeneration based on low-cost energy, based on shale gas and the amazing new oil reserves, which are being discovered in America. On the other hand, you have countries like China and India, who may indeed be investing in green technology, as I'm constantly told, but they are investing a great deal more, in fact, in coal-fired power stations, so that the effect of what Europe is seeking to do in reducing emissions is completely swept away by the increase in coal consumption in other countries. And even what Europe thinks it is doing is not actually being achieved. We take pride in the fact that Europe only represents around 11% of global emissions, and that is true if you look at emissions within Europe. But if you look at emissions associated with products and materials consumed in Europe, in other words, taking account of the CO2 emissions implied by the production of goods that are subsequently exported from their home countries, from China, for example, into Europe, then we are responsible for about 25% of global emissions, even though fewer of those are actually generated within Europe. That, I think, gives you just a little bit of background as to why I take the position I do and why I'm interested in bringing this story of the alternative views of CO2 and of climate to the widest possible audience. We face a situation where groupthink is established on a very strong basis throughout the scientific community. And we are told, for example, that the IPCC panel has some 2,000 scientists who are all united in their support for the orthodox position. When you actually check it, you find that only a minority of those 2,000 reviewers and writers are actually scientists at all. Many of them are activists in green organizations. Many of them are civil servants. Those who do have qualifications are frequently qualifications in other areas. For example, there are quite a number of economists there, and I'm sure economists are very sound people, although some of the forecasts they've made recently about the British economy have not been entirely correct. But I don't see they have any particular expertise in matters of climate. Now, I'd like just to touch on one other point, because, of course, I'm presenting two speakers today, both of whom are highly qualified in their respective fields, but neither of them, let's be honest, is a climate scientist. There is a good reason for that, and that is there are a great number of climate scientists who actually take a sceptical view, and if we had time, I would go on to talk about the famous 97% consensus, which is even more suspect than the hockey stick. But people who have written extensively and popularized these issues often have a broader view of the whole scene. In fact, climate science is not a single science. It is a great number of sciences that are rolled together in a package, and a highly qualified scientist doing research in the area may well only be covering a small fraction of the field, whereas people who have written extensively and sought to popularize the issue do take a broader view. In that context, I would say that it often happens that people say to me, why do you think you are entitled to an opinion? You are merely a politician. You are not a climate scientist. And I have to remind them that politicians are, of course, elected to make decisions. And frequently, we politicians find ourselves making decisions, almost daily, making decisions on technical areas in which we have no particular expertise. So where those technical areas are well understood and well agreed, and where a genuine consensus exists, I think generally we pay attention to it. But when we come to areas that are disputed, and indeed this area is disputed vigorously, then we have to form a view which we believe is in the best interests of our constituents, and I have done that. So I am entitled to take a view because it is my job to take a view. Others are, of course, entitled to take an alternative view. Now, with that, I'd like to introduce our first speaker, who is the Reverend, if I may say so, the Reverend Philip Foster. Philip has a degree, in fact, he has 2 degrees from Cambridge University. One is a degree in theology, which may or may not be relevant to the issue of climate science. The other is a degree in biochemistry, which certainly indicates to me that he has a good grasp of scientific principles, but I've known him for a long time as a doughty campaigner on the climate sceptical side of the debate, and a remarkably well-informed campaigner. Alongside Philip is Christian Gérondeau, illustrating that this is not a primarily Anglophone point of view. He comes from France. He is a distinguished engineer. I will say a little more to introduce him later on. But right now, I would like to give the floor to Philip. Philip, please.
Well, thank you, first of all, for inviting me, considering the fact I think I asked Roger if he would set this up. That's a bit rude. Do I need to turn this on? That's better.
Yes,
How
good.
about that? Yes,
Very
thank
good.
you for inviting me. I'm just thinking, people around there, can you see the screen? That's okay, that's fine. That's important. Well, I thought I'd have a nice provocative start to my talk. Why carbon dioxide is good for us and for the planet. And there's a lovely picture there. And I wondered to myself whether that was Donald Trump's mother's house, but I don't think it necessarily is. But anyway, thank you very much for inviting me. As Roger said, I am a campaigner on this, so I must be treated accordingly. I have, unfortunately, written a book on it. It's called While the Earth Endures, Creation, Cosmology and Climate Change, which does to some degree combine my theology with scientific ideas. If you have a copy of that, I would like to part you from €10, but the other booklets, with the exception of Gérondeau's book, are free. There's a booklet, I'll touch on issues of this, called Climate, What We Know and What We Don't. This is not, in inverted commas, by me. It's a summary of work done by Professor Murray Salby, an American professor of atmospheric physics at one point at Macquarie University in Australia, and that's available for free. There's a kind of extremely summarized version of that, which I've called Settled Science, which sort of does it in 4 pages. There's also another little flyer, which is a matter of interest. I'll not discuss it today. How much fossil fuel and hydrocarbons is there on the planet? Which is a novel way of looking at what kind of hydrocarbons we have left, because people say it's going to run out in 10 minutes. I'll touch on this very briefly. We did a counter-conference to COP21 in 2015, which we called the Paris Climate Challenge, which was a follow-up to a previous conference we did in Copenhagen in 2009, called the Copenhagen Climate Challenge. This book contains a number of essays by a number of experts in their fields, anything from polar bears to other issues concerning climate. These are, what's left of them is available, and you just take it away for free. Right, enough of the advertisements. Let's proceed on. Why carbon dioxide is good for us and for the planet. I'm going to have to go backwards. I like my picture of the solar system. Well, it's a galaxy, not ours, but as a Christian, I like to have the heavens declare the glory of God and the skies proclaim the work of his hands. Think Haydn, the creation, a wonderful, joyful thing of that. Right. People seem to think that there is some classic climate which everything should conform to, what I call the Camelot view. Those of you who know the musical Camelot know that in Camelot, Britain, the sun always shone by day, the rain always fell at night, snow fell evenly from whenever it was to December through to February, whatever it was, and, and so forth. There is no such thing as a good or bad climate. Climate is always changing, always shifting. One of the insults slung at people like us is that we're called climate deniers, which is a fascinating concept. The idea that you can deny that climate changes is clearly ridiculous. It does change, but what matters is the cause. I want to go back to another clergyman gentleman, the Reverend Thomas Malthus, who decided to do some mathematics, and there's nothing wrong in that, and he calculated that if the population of the planet reached 400 million, we would all starve to death or die of disease. This is known as Malthusian ideas. And to be perfectly honest, although he was grossly wrong, not because of his maths, but because he had no understanding of how things would develop in the next couple of 100 years in agriculture, we now have a population of 7 billion. And although there are, tragically, people with insufficient food, and indeed some are starving, nonetheless, a very high proportion of people have enough to eat. And 6 or 7 billion people, he was way wrong. Right, let's go the right way. That's it. Anybody know about Dr. Ignaz Semmelweis? No takers? Hungarian physician, and he was, I suppose, what we might call a gynecologist, somebody concerned with people who are given birth, and the hospitals in, I think it was Vienna he was in, the mothers, I think many of them were prostitutes from the streets, because most people gave birth at home with their family, of course. They were in these wards, and they were dying like flies, not only the babies, but the mothers, primarily from puerperal fever. And he realized why. The young trainee doctors were coming from the pathology laboratory and examining these living women, and they never washed their hands. And the result was, of course, they were bringing infections from the path labs and killing women in their hundreds. So he insisted that his doctors and his trainee doctors wash their hands before they examined their patients. And the death rate plummeted as a consequence, pretty obvious to you and I. No one would believe him. He was sacked from that hospital because he was too much of a nuisance. He went to another hospital, instituted the similar regime with similar consequences. He was sacked from that hospital, and the poor man finally ended up in a lunatic asylum because he couldn't cope with the screams of the mothers dying in the hospitals because people would not wash their hands. Here's another man who swept the board in Soviet Russia, Trofim Lysenko. He believed in a certain pseudo-genetics about breeding crops. He was terribly wrong. Millions died of starvation, and yet he survived in 1976. So we get these things happen. Here's another man, Alfred Wegener. Plate tectonics, the fact that the Earth's continents move around. He came up with that theory in the 1930s. No one believed him. Now, of course, everyone accepts it. Now, we're all saying that we're not necessarily expert in climate science, but we are scientists or engineers and have some way of how science works. However, having said that, so many of the people who lecture us on the issue of climate are themselves not particularly expert. I mentioned the previous head of the IPCC. Arguably, he was a railway engineer. That was his career, but not necessarily an expert in climate. And yet he was heading up the political organization of the IPCC on the issue of climate. In Britain, we have Professor Sir Mark Walport, who is chief government scientist, and his qualification is he's a doctor. Okay? Some of you may have heard of Bob Ward of the Grantham Institute. Yes, he has a degree in geology, which is quite helpful, but he didn't finish a PhD in the same. He is funded by Jeremy Grantham, who runs one of the biggest green investment firms probably in the globe, who funds this. It's necessary for Mr. Grantham to maintain the impetus on green investments, otherwise his investments will fall. Mr. Bob Ward is his Rottweiler. Then, in Britain, we have the BBC. I know this is slightly tongue-in-cheek, but it says where science reporting means asking Greenpeace what they reckon. Roger Harrabin is the BBC environment analyst, and his qualification is English. He doesn't know about science. There is not one scientist in the reporting staff of the BBC, not one. So when you hear our science correspondent on the BBC, think probably qualified in PPE. That's the way it goes. There is, of course, our beloved Prince, Charles, for those who don't know who he is, who has recently come out with a Ladybird book on climate change. We are preparing a cheery response to that little booklet. Ladybird used to be the stuff for boys and girls, and I must admit, I've read it, and it's stuff for boys and girls. It's pretty illiterate. There's not a single reference throughout the entire book. It's meant to be for adults, nowhere to go and look and check things up. Then we have Sir David King, FRS, and he was the man who prophesied Antarctica is likely to be the world's only habitable continent by the end of this century if global warming remains unchecked. Okay, why isn't he buying real estate in Antarctica? Paul Ehrlich, who is perhaps the great prophet of the green movement, still with us. He is an amazing character. He has produced so many wrong prophecies that, you know, if I had a euro for every wrong prophecy, I'd be a euro millionaire. He's an amazing guy. And there are plenty of these false prophets around. Paul Ehrlich, for example, our gentleman, in 1981, prophesied by the year 2000, half the species on the planet would be extinct, and by 2015, all life would be extinct. Are we alive out there? We are. I'm afraid, from a biblical point of view, this is what we call a false prophet. There's a good Old Testament text which, when the Israelites thought, how do we know when a message has not been spoken by the Lord, in other words, not a true prophecy, if what a prophet proclaims in the name of the Lord does not take place or come true, that message the Lord has not spoken. The prophet has spoken presumptuously, do not be afraid of him. Or, to summarize, one strike and you're out. If you get it wrong, forget it. We're not going to listen to you anymore. He actually became an honorary member of the Royal Society. So there you go. That's what happens to false prophets. However, more sensible scientists like Einstein understood how science really works. No amount of experimentation, he said, can prove me right. A single experiment can prove me wrong. Now, some climate myths, where in fact there's no actual evidence, but the language of could, might, possibly is very much in evidence. The first one is the belief that global warming will cause more extreme weather. Have you heard that? We'll get more storms, more floods, more winds, more hurricanes, and so forth. The cause primarily of, if you like, extreme weather is the contrast between the cold pole and the equator. The difference in temperature is what generates all the excitement and all the storm. Well, not all, but it's a major factor in doing that. That's where the energy difference comes from. In a warming world, the poles become less cold by quite a lot. And this is a sort of guesstimate. Let's say it would warm by 15 degrees. Whereas the equator is unlikely to warm more than a degree. This is an extreme warming. It will probably get wetter. The result? The temperature difference has dropped. As a result, there will be less extreme weather in warmer climes than in colder ones. Now, anecdotally, which is not so easy, I hope anyone from Spain here? Well, I can tread carefully, but the Spanish Armada was defeated not so much by the British Navy, but by terrible storms that erupted in the end of August around our coasts. And this is a medal which has the wonderful thing, God blew and they were scattered. This was in the middle of what we now call the Little Ice Age, when in fact Earth's temperatures were quite low. And as a result, weather was more extreme in odd periods of time. Here is another quote from 1595 of a fellow clergyman of mine. Our years are turned upside down, our summers are no summers, our harvests are no harvests. The weather was pretty grim during the Little Ice Age. I'll come back to that. Well, have storms increased over the last 30 years? Well, here's a measure of US tornadoes beyond a certain level. There was a peak in 2008, but in fact the trend currently is lower than average. Here is hurricane storms globally, which measurements began in about 1971 through to the present day. Here is as it were, the number and intensity of them. There is no particular pattern at all in hurricanes. If anything, currently things are relatively low. Incidentally, you will hear Typhoon so-and-so is the biggest ever. Have you heard that? The biggest ever. Since when is the question to ask? Well, since 1971. That was when measurements began. Anything before that, we don't know anything about in terms of how big or small they were. So be careful when somebody tells you something is the biggest ever or the highest ever. From when is the question to ask. Then you're told the glaciers are melting. Well, there are about 160,000 glaciers on the planet, of which about 160 have been monitored. So that's 0.1% of them. Some of which are indeed retreating, that means they're melting, but some are advancing. I might add that there is one valley or two valleys in Alaska which contain two glaciers, and one glacier is advancing and another glacier is shrinking, and they're next door to each other. Clearly, what causes glaciers to melt or advance tend to be local conditions, not global conditions. Polar bears. The polar bears are in a terrible state. They're all dying out. Incidentally, if you want to know more about polar bears, go to Dr. Susan Crockford's website, www.polarbearscience.com. Fascinating. She's an expert on this kind of thing. When Al Gore was born, there were 4,000 polar bears. Now there are only 30,000 left. Things have got good for polar bears, I may add. They feed on seals, incidentally, and seals, who are quite cunning little creatures, what they do is to put their young on top of an ice floe and bury it in snow so it isn't visible on the ice, and they feed it from underneath. It so happens that areas where polar bears are struggling is where the ice is too thick for the seals to burrow up underneath and feed their young, so they move or die off. And so the polar bears don't have their food. That is because the ice is too thick, not because it is too thin. Actually, Antarctic ice, which is we're often told is in a terrible state, well, here actually is a chart for the last 18 years of extent of ice in Antarctica. It's all sea ice, of course. And what is interesting is there hasn't been a vast amount of change. It is slightly less than there was, but notice the average depth of ice has been increasing over the last since 2008, yes, nearly 10 years. Going to the other end of the Earth, to the Antarctic, sea ice extent in 1999, and the yellow bit is a sort of median, and the sea ice extent in 2016. Well, there's no big difference there. If anything, 2016 is marginally more than it was in 20 or so years ago. Incidentally, it's not on the map, but the thickness of ice in most of Antarctica is increasing, not decreasing. So it's actually getting colder down there. Where, anyway, is all the land ice that's going to melt and drown us? Well, Three main places, obviously Antarctica, Greenland, which is another land-based ice mass, and of course the rest of the world, all the mountains and so on. Well, 90% of all the land-based ice is in Antarctica. It's a huge continent. Greenland holds about 4%, and the rest of the world 6%. Now, Al Gore told us that if Greenland melted, sea levels would rise several feet. It's most unlikely, it's not actually melting, but even if it did, it wouldn't have that huge effect. Most of the ice is in Antarctica, and Antarctica, if anything, is cooling and thickening. Another myth, the oceans are becoming acidic because of all the carbon dioxide. The oceans cannot become acidic, period. It's impossible. Physically, geologically impossible. Summarized beautifully by Professor Ian Plimer, who's a geologist, the oceans can only become acidic if the Earth runs out of rocks. It's as crude and as simple as that. How many of you remember your chemistry from school days? A few. The test for carbon dioxide. You bubbled carbon dioxide through a liquid called lime water, which was basically a solution of calcium hydroxide. And what did it do? It went cloudy. Remember that? White cloudy? You have one or two nods. Then if you went on bubbling it through, it went clear again. Because first of all, it formed calcium carbonate, and then it formed calcium bicarbonate, which is soluble and alkaline. So the more CO2 that is dissolved in the oceans, the more bicarbonate will end up in the oceans, which will balance any acidity from the carbon dioxide. It is called a buffer solution to us chemists, and the oceans are permanently buffered because of the presence of limestone and other carbonates like that. Rivers and lakes can, because that will be local geology, but not the oceans overall. So that's another myth that can be dismissed. Sea levels I will touch on again. This is work done by Professor Niels Axel Mørner, his Swedish sea level expert, around the Indian Ocean. And he shows, and has been measuring this from tide gauges and so forth, that there have been times of stable sea level from 1875 to 1900, a time of rising sea level from 1900 to about 1955, 60, and in the current years, the sea level has reverted to being level again. The Indian Ocean is not in a serious problem. The Maldive Islands became very familiar in 2009 when the president of the Maldives held his cabinet underwater to prove that they were drowning because of American burning of fossil fuels. Well, the same Professor Niels Axel Mørner did a survey of the Maldive Islands for their government, which they promptly suppressed, for the simple reason that the sea level around the Maldive Islands had fallen by 30 centimetres, which is huge. It had dropped, not risen. The business of this tree is an interesting case in point. The tree is on the shore, as you can see, a lone tree. It was always a recognizable landmark, particularly apparently from prisoners returning from one of the prison islands. And he had seen that and realized that gave him an indication of how far the sea was coming up. Then he discovered by accident that the tree disappeared, and he thought he got it wrong, which is a good scientist. My evidence that I was basing it on is gone. Clearly, I have made a mistake. Well, he then discovered by talking to people in the local cafe that the tree had been pulled down by some so-called Australian scientists in order to make it look as if the sea level had risen. That was a pretty shocking discovery. Now, the truth is, global warming, what global warming? There has been no noticeable global warming for the last 20 years. And here's a graph, as it were, that shows from 1997, there was a spike in 98, El Nino, there's an El Nino last year as well, which tends to push temperatures up, not for carbon dioxide reasons. NASA itself admitted that anyway, it's almost impossible to decide whether there was a hottest year because the margin of error is 7 times bigger than the temperature they are claiming it has increased by. It's increased by 0.01 degrees centigrade with an uncertainty of 0.07. So in other words, if you're saying it's moved this much, but it could be either way by 7 times as much, is telling you nothing. In other words, there is no way of saying that any year is particularly warmer than another in the last 20 years. There has been, therefore, what's called a pause, and a good friend of mine, Josh, who likes doing cartoons, there was a problem. How do you explain the pause? Well, everybody thought they had an explanation. Other people said there wasn't a pause at all. We'll come back to that. I think Christian will touch on that. But this was a little cartoon. I've got 60 excuses right here, pal. Cognitive dissonance, you see, in full operation going on there. However, and I'll go quickly through this because I know Christian has more to say, a strange thing began to be noticed around 2 or 3 years ago about thermometer stations, temperatures. This is Iceland, in a completely unpronounceable island which has got a thermometer station on it. And in 2012, the version of temperature ran like that. There was some missing data. That's what it looked like in 2012, according to the station. Suddenly, in 2014, it completely changed. There you are. That's what it was in 2012. And suddenly, in 2014, it was completely different, showing a graphic rise up, whereas it, in fact, showed a down and then a up again. Very odd. And then people began to notice that this seemed to be happening not just in funny little places like Iceland, but in fact right over, for example, the US temperature. That was the measured, and I've traced it out from NOAA, what it was measured to be, and then what they published or reported was that. Something's going wrong somewhere. What they've decided is that people in the past couldn't read thermometers, and now they can. As you know, the 60s and 70s, when they sent men to the moon, they couldn't read a thermometer. But now we can. So we've got a problem going on here, and not all is honest, I fear. Again, my good friend Josh has a nice curve for us there. One of the problems, particularly in the US and elsewhere as well, is where are these weather stations? Well, in this case, here's an example of one on an airport, Henderson Field. That little arrow there shows where the Stevenson screen and the instruments are, and notice where it is. It is in the slipstream of the jets as they come by. So you can imagine a spray of hot jet gas moving past the Stevenson screen. Up go the temperatures. Not surprising. Here's another example out in the countryside in California, a Stevenson screen set up right next to a wodge of tarmac. And if anybody has ever stood on a tarmac in hot weather, you'll know how very warm it will rise off the tarmac, which of course will affect the temperature in that box there. So we've got a lot of problems. Also, in the 1990s, they cut the number of weather stations they used for measuring the global average. Now, coincidentally, that was when the temperatures went up. Now, that may be wholly unconnected. Correlation doesn't prove causation. But it is interesting that when they cut the number by nearly 60%, that was the time when temperatures apparently went up, global averages. And we have to remember that all ground-based weather stations, by default, are proxies of temperature, simply because the data, such as they have, has to be homogenized, that is, corrected by guesswork to fill in the gaps for the many millions of square kilometers of land without any temperature coverage. So they just guess in between. Now, they may guess right, but who knows? So the data you're dealing with has been homogenized, and therefore we can't be sure that it's measuring anything serious. Only really the satellite data gives anything like a true picture of global average temperature. Quick run through the past. This is from 6 million years ago. This is based on another proxy system. Can't have time to explain it now. Oxygen 18 to oxygen 16 ratios in rocks and so forth. What we generally see is that the Earth has been trending slowly downwards in temperature. We are cooler now than we were 5 million years ago. I well remember those warm days. Okay, this is the last 11,000 years, which we came out of the last big glaciation. Temperatures rose. There were periods of considerable warmth from 8,000 years ago, and these have various assignations: Egyptian, Minoan, Roman, medieval, and the current warm period. That's how they relate to each other. There's nothing particularly, as Roger said, apparently alarming about the modern warming. It seems no different to any of the other periods of warming, in some cases not as big. So that's worth bearing in mind. We came out of an ice age and we're in a warm period. Notice this period of time is the time that human civilization exploded, from the first farming to where we are now. For good or ill, that's where we are now. And it's all during what's called an interglacial, between big ice ages. Ice ages last some 80,000 years, and interglacials 10 to 12,000 years. Bear that in mind. I'm not prophesying anything, but we've been around a fair while during an interglacial. Here is the hockey stick, this red line here, which Michael Mann, which Roger referred to, and here is the original curve that was available in the first IPCC report, produced by Hubert Lamb, who was a professor at the Climatic Research Unit at the University of East Anglia before things went pear-shaped. And in fact, they pushed him out because he wasn't actually agreeing with the new scenario. A medieval warm period, the Little Ice Age, which I've referred to, and the current warming, not as great as the medieval period. This clearly was an embarrassment to the IPCC. What are we worried about if, in fact, it was warmer in the medieval period? So when Michael Mann came up with his magic hockey stick, no time to discuss why it's wrong, they grabbed it. The last 100 or so years, global temperatures have peaked in the 1930s when they were quite warm, went down again during this period here, and has gone up again to where we are now. It's worth noting that during this period, the dotted line represents rising CO2, temperatures were falling, until CO2 was rising. They were diverging. And yet, according to their theory, CO2 is driving temperature. Well, it's not showing much sign of it there. This is the same curve, only this time the scale is different. As you notice, it's a very small scale here, very little movements, points of a degree. If we go on here, this is an average day in a desert, from plus 40 to minus 4. So you've got a 44, 50-degree change in temperature in 24 hours. And that's what the same line would look like on the same scale. In other words, what's going on here? It's noise in the system. Hardly worth noticing. Here's the same curve with the much more error bars. These bands here are the two areas where temperatures rose, the two periods where temperatures have risen that has caused the modern warming. Here are the same bits broken down into two sections. And it's deliberately such you don't know which is which. Which is the earlier one, that one there, which would be caused by nature, and this one supposedly caused by us. Which of the two is which? You can't tell. The rate of rise is much the same in both cases. Now, to my main topic. You thought I was going to get there eventually. Is CO2 the most dangerous gas on the planet? It's a colourless, odourless, life-giving gas, essential building block of all life. Every single one of us are made from the products of carbon dioxide. People like Stuart, who plough the fields and scatter, produce the food that we eat, and which is all made almost entirely of carbon dioxide. It's the essential building block for all life. When we burn fossil fuels, like oil or whatever, actually we end up making wheat. 1 ton of aviation fuel burnt produces 1,500 average loaves of bread. Worth thinking about next time you go flying. I'm making bread. There has been a 20% increase in what's called the biomass in the last 35 to 40 years, approximately speaking. And we need to ask the question, does CO2 cause global warming or climate change? And which I'm going to say no, it does not. Climate, whatever it's causing it, drives carbon dioxide levels. But as I said, it does cause everything to grow. CO2 levels are currently, yes, this is correct, dangerously low. I'll repeat that, dangerously low. If they were to halve, almost certainly vegetation would die out, and we therefore would die out with it. As it said, 200 parts per million, plants would start dying. Trying to cut carbon dioxide kills people. because people who are on the edge of starvation, just managing to survive on the crops, if you cut the CO2, the crops will fail and they will die. So I have my slogan, cutting carbon kills. Here is an interesting map of the increase in greenery by percentage over the last 30 years. Quite remarkable. Particularly notice the southern Sahara, how much increase in vegetation there is. There's an interesting reason for this. The increase in CO2 is one of it. The second thing is that when there is more CO2, plants tend to use slightly less water because they rely on sucking in CO2 through stoma, little mouths on their leaves. If there's more CO2, they don't need to open their mouths so often. And when they open their mouths, just like we do, they breathe out water vapor. But if they don't do that so much, they don't use quite so much water, which is probably why, in particular, scrub vegetation and so forth is encroaching into the southern Sahara. Now, CO2 has reached 400 parts per million. How much is 400 parts per million? What does it look like? Well, imagine a crowd of 2,500 people. There they all are, just head and shoulders. If it's a sort of football stadium and you imagine this crowd of people all sitting there, how many are supporting the home side, the nitrogen team? Well, about 79% of them. 20% of them are the away team, the oxygen team. However, creeping into this crowd have come one or two others from different football clubs. There's the argon team, and they're 1% of the crowd, the little yellow guys here. But where is our man in the carbon dioxide shirt? Okay, we've got one man in that crowd who represents the total amount, proportionally, of carbon dioxide in our atmosphere. Just one. How much of that carbon dioxide comes from what human beings, are generating through fossil fuels? Now, to do that, we have to multiply that crowd by 25. So that's a crowd of 62,500 of them. Each of my little banks of them has got a tiny little red dot. I think you can just see it, hopefully. Only one of those represents the human contribution to atmospheric carbon dioxide. You getting the picture? And that, according to the IPCC, is the driver of our climate. That one little guy out of 62,500 is causing all the climate change that we're being alarmed about. I quote, "All these increases in carbon dioxide from pre-industrial times are caused by human activity. The increase in atmospheric CO2 concentration is known to be caused by human activities because the character of CO2 in the atmosphere, I'll come to this, in particular the ratio of its heavy to light carbon, 13 to 12, has changed in a way that can be attributed to addition of fossil fuel carbon." This is impossible. Impossible scientifically and practically. It's impossible that that could be true. And I'm going to come to why. We're going to have to do a little bit of climate history now, or solar system history. The four rocky planets, Earth, Venus, Mercury and Mars. We can forget Mercury, it's got no atmosphere at all. The Earth's atmosphere is 0.04% carbon dioxide. That's the 400 parts per million, roughly. We have an atmospheric pressure of 1 bar because that's what a 1 bar is, 1 atmosphere pressure. Our closest neighbour to the Sun, Venus, has 90 atmosphere pressure and has an atmosphere 95% of carbon dioxide. Mars, which has a very low atmospheric pressure, because most of the atmosphere is blown away, still has 95% carbon dioxide in its atmosphere. Why is this Earth so different? Well, it's pretty obvious in a sense. Life. Life has sucked the carbon dioxide out of the original Earth's atmosphere, unlike Venus and unlike probably Mars. Let's have a quick spin through. 4.5 billion years ago, the planet Earth was formed, and this is very approximate, we're rushing quickly. The atmosphere was almost entirely carbon dioxide, that's red. The dotted line here represents atmospheric pressure, which was 100 atmospheres, and it is today. Going hastily through about 2 billion years, around that we have evidence that the CO2 level was this high from some very ancient rocks, barytes or barytes, which have CO2 crystalline within them, which could only have got in if the pressures were greater than 60 Earth atmospheres. About at this period, we have the first cyanobacteria, which began to do something amazing. Began to take carbon dioxide, take out the carbon, throw away the oxygen, and turn the carbon into more life like itself. And this went on for nearly 2 billion years. 2 billion years. And as you can see, as a result of that, atmospheric pressure began to drop. But you may ask yourself, what's happened to the oxygen? The Earth rusted. The iron oxide that we now dig out as iron ore started life for the most part as iron. And the oxygen from the cyanobacteria rusted the planet's crust. And it was not until the rusting had been complete that blue oxygen began to appear in the atmosphere with a rapid fall. Nitrogen was producing geologically from the rocks, which is an inert gas. Then we come to the last period, the last 700 million years. At about 700 million years ago, it is thought with reasonable evidence that the Earth became a snowball, that there was ice as far as the equator. Notice that the CO2 level was nearly 30% at the time. CO2 causing global warming, ice ball Earth with CO2 at 30%. CO2 continued to be quite high in the atmosphere, 20–30%, right until about 606, or whatever it is, 0.66, 6 million years ago, with the KT boundary. That was probably a meteorite impact that ultimately did for the dinosaurs, mainly because the oxygen level fell by 10%. And big dinosaurs needed a lot of oxygen in order to survive. And they wouldn't get it at that level, so they died out. Right back at the early life of period, here the Paleozoic, you have enormous, this is a dragonfly, wingspan of 2 foot 4 inches or 70 centimetre, huge creature, relied on a thick atmosphere with a lot of oxygen. That's the only way it could have survived. Much later on, you have the flying pterosaurs, similarly relying on a thick atmosphere of 3 or 4 atmospheres at that point in order to glide and fly. A modern one of those, if we launched it out here, would fall like a sack of potatoes on the ground. It couldn't support itself in flight. And dinosaurs died out. Here's the same graph in a different way, just to point out one further thing. With oxygen as high as it was, nearly 30% or more, the danger would be that forests would spontaneously burst into flame because of the high oxygen. By good fortune, or possibly design, there was a fire extinguisher to hand, high carbon dioxide. Carbon dioxide is an excellent fire extinguisher. This prevented major conflagrations of vegetation during that period. Now, the claim on the warmist side is that these are the evidence that they claim that fits their data. The ice core data, modern rising levels of CO2, well, we've looked at that and seen that there's no big deal there. And third, and this is a key but rather subtle one, the increase in deep fall in proportion of carbon-13 in the atmospheric CO2. Carbon-13 is a heavy molecule, heavy atom of carbon, which living material tends not to like. It prefers standard carbon-12, not carbon-13. Carbon-13 is not radioactive, but it is heavier. Okay, first of all, the ice cores, much used by Al Gore. Here is the trace of temperature, CO2, and methane. Notice, incidentally, that CO2 and methane go together. There is a good reason for this, because methane comes from rotting vegetation, just as carbon dioxide comes for a vast amount from rotting vegetation. Anaerobic rotting of vegetation produces methane. Aerobic, that's air breathed, produces carbon dioxide, and they go together. However, Al Gore claimed that it was the temperature driving these. The CO2 and the methane that was driving temperature. This is incorrect. If you look more carefully at these, you discover that there is a lag between the peaks of carbon dioxide and temperature of about 1,000 years. The temperature goes up first, and then it's followed 1,000 years later by a following spike in CO2. So the idea that CO2 is driving temperature in the ice core is simply wrong. Al Gore, I think, knew that when he made his film, but he said it's complicated. Yeah, sure is. Cause and effect can't be reversed, at least not in science. And in fact, it was known right from the beginning. Jim Hansen of NASA, told a reporter, I can give you the text of this if you email me, that in fact the carbon dioxide changes do seem to follow the temperature changes, not precede them. He knew the ice cores did not support the idea that CO2 was driving temperature way back in 1989, which was only a few months, I'll talk about the reason, 16 months after Hansen's infamous declaration to the US Senate that catastrophic man-made global warming had started. He knew all along that CO2 was not driving temperature, at least not in the past. Here they are taking an ice core, or at least a small one. Here they are drawing it out. You can see there are bubbles in the ice, but there is a problem with actually that trace of CO2 and methane with temperature. Because when you take an ice core out of the ground, the lower the ice core starts from, the more pressure it has been under. And way down at 400,000 years ago, where the sort of ice cores start, the pressure was probably 400 to 500 atmospheres. If you pull it out, what happens? It outgasses. It cracks the ice, and the gas that's trapped there, which is under 500 atmospheres, goes. And when you pull them out, you can hear the ice core fizzing because it's releasing air. So what we measure in the bubbles is not actual amounts of air quantity at all. It's a ghost of what was there. That is all. And in fact, Murray Selby calculates that 100,000 years ago, the ratio of the amount of CO2 in the ice cores would have been much higher than is measured, which makes sense because we know that old Earth had a lot more carbon dioxide than we do now. Here's the global carbon cycle, what's going on. Huge shifts between the natural greenery and the air. Enormous amounts of carbon dioxide are being both absorbed and emitted by rotting vegetation. Similarly, in the oceans, there are huge exchanges of carbon dioxide. As the oceans warm, CO2 comes out of them. As the oceans cool, CO2 is sucked into them. This tends to only happen in the top few meters. Below that, the oceans are permanently saturated in carbon dioxide. Human emissions are relatively small, as we've already seen, in comparison to the huge effects going on here. Other effects, not in that first one, volcanoes produce a certain amount of carbon dioxide on land, not a vast amount, probably not as much as we produce, but what we don't know anything about is the undersea volcanoes and how much they are producing. All we do know is there are many, many more undersea volcanoes than there are on land. And they are generating CO2 at the base of the ocean in quantities unknown. Interestingly, in the very deep crevices of the ocean beds, there is liquid carbon dioxide. Under such pressure and under such low temperature, it will liquefy, and there it sits, undissolved. And those of you who are chemists tell you that, therefore, that this solution is saturated in carbon dioxide permanently. So there it is all joined together. Right. Going to have to think now, just when you thought you weren't going to have to. Here's the temperature plot from 1960 to the more or less the present day, and the green is the CO2. It goes up and down seasonally because most of the greenery on the planet is in the northern hemisphere, so it will be seasonal, not compensated by what's going on in the southern hemisphere, which is mostly ocean. However, as you can see, the rise in CO2 is steady, straightforward. The rise in temperature is very fluctuating. And particularly note, as the CO2 is continuing to rise here, the temperature has flatlined. Now, they mention this strange business about carbon-13. And correctly, they say that because organic material likes carbon-12, not carbon-13, and, they claim, the amount of carbon-13 in the atmosphere as carbon dioxide has falling, they say, well, because fossil fuels come from organic matter, it follows that the decrease in carbon-13 is because we are burning fossil fuels. There is a huge hole in that argument because they are omitting to realize, just to go back a couple of things, this. Here, vegetation is releasing carbon dioxide in huge amounts. Vegetation, modern vegetation, doesn't like carbon-13 either. So all that CO2 that is being emitted will be low in carbon-13 because it's organic. The human amount is very small. Here's my little thing. Plants like carbon-12. They don't think a great deal of carbon-13. So their third plank, that carbon-13 is proof of human activity, is wrong. It's wrong scientifically. It couldn't possibly be our contribution, particularly because at the same time as CO2 is rising, so is methane. And that is the giveaway that we're looking at organic decay, not human emissions. I'll spin through these just to speed things up a bit. Here we have a rise in CO2. There we have a very simple rise in temperature. Interestingly, when temperatures were rising, CO2 levels were increasing quadratically. That is, they were moving up and up and up and up. When the temperature flatlined, CO2 rates began to go linear, which means they were slowing down. The rate of increase was slowing down because temperatures were flatlining, because temperature drives carbon dioxide. Here, this is an interesting one. This is the rate of increase of consumption of fossil fuels globally. And from 1990 to 2002, the rate of increase, which means increasing year on year, was a line roughly like that. In 2002, because so much more was coming on stream in China and Brazil and India, the rate tripled. The consumption rate has tripled. So it shot up like that. Now, very interestingly, if we put it back on this curve, CO2 levels have slowed, temperature has flatlined, human consumption has tripled. The three don't add up. If human consumption is generating the carbon dioxide that is causing the rise in CO2 and rise in temperature, then this tripling should surely increase the amount in the atmosphere, the rate of increase. It is not. It's slowed. Similarly, the temperature flatlined, so clearly the three are not connected. There is no relationship between human consumption of fossil fuels and natural CO2 in the atmosphere. There it is in a more simplistic form. Now, if CO2 from human emissions was responsible for the rise in carbon dioxide and therefore temperature, these are the areas where you would expect highest levels of CO2 to be. Heavy industry and so forth, in America and Europe, and particularly in China and parts of India. That's what you would expect if you calculated it from fossil fuel consumption. This is the actual map as measured by satellite. The blue areas represent CO2 sinks, disappearance of CO2, and the orangey areas represent increase. What we're seeing here is the actual amounts of CO2 excess over an average measured by satellite, not a calculation, measured by satellite. And what we see is roughly what we would expect. Most of it comes from where there is maximum rate of decay of vegetation around the tropical belt. That's what you would expect. There is no evidence of excess CO2 over the areas of heavy industry at all. And that's the data. There is no evidence at all. There's the calculated map. That's where it's all supposed to be. And that's reality. It's all nearly all in the equator. How long, this is another claim, this is another horror of the IPCC, the emissions of CO2 will remain in the atmosphere, they say, for 200 years. So it's going to accumulate and accumulate because we're not getting rid of it quick enough. Again, rubbish. There's no other word for it. As it happens, serendipitously, as we say in English, by a fortunate freak of political circumstance, we have a measure of the speed at which carbon dioxide disappears from the atmosphere back into vegetation and so forth, or in the oceans. In 1963, there was the Nuclear Test Ban Treaty. This stopped nuclear bombs being tested in the atmosphere, and when they did that, the explosions generated carbon-14, which is radioactive carbon, and generated, therefore, as a result, carbon-14 CO2, which can be measured easily because it's radioactive. It's easy to measure. It's a useful tracer. And that has been measured. And the fall in carbon-14 CO2 follows that curve and has gone right down to there within 20 years. That pink line is the IPCC model. That line there shows actual reality for carbon-14 disappearing from the atmosphere. But there is a further proviso here. Remember I said plants like carbon-12, they didn't like carbon-13, and they really don't like carbon-14. So the disappearance of carbon-14 is not primarily probably because of plant absorption. Plants don't like absorbing it. They will absorb some, but not very much, because they don't like it. So the rate at which the carbon-14 disappears is probably far in excess of the rate at which, bigger time than ordinary carbon dioxide, which will probably disappear within a few months, because that's what plants like. They're sucking that in like anything, whereas carbon-14 they don't like. So back to what the IPCC had said, that all the increase in CO2 is due to human activity. This is simply impossible. And in fact, human emissions, forgive this slightly crude analogy, is that by, forgive me, pissing in the ocean will increase the levels of the ocean. It's the same with putting our CO2 into the atmosphere would increase the levels of CO2 in the atmosphere. It's almost unmeasurable. I may add in passing, do you remember I talked about methane going in tune with CO2? If human emissions are causing the increase in CO2, what is causing the increase in methane? As Murray Salby rather bluntly put it, only if burning fossil fuels also produces flatulence would you expect the two to rise together. Sorry about that, but I think it's actually rather neat. I'll move on from that. We touched on computer modelling. Remember that models are evidence of nothing. Here's something, a headline a few days back, well, about a couple of weeks back. This is an economic modelling. Forecasting the next crisis is beyond us, warns Bank. Economic models cannot be sufficiently accurate, warns Monetary Policy Committee member. If economic models cannot model economies, there is no chance whatever that climate models can model climate, because climate models are a highly sophisticated sort of computer system to an abacus for economic models. Economic models are a doddle in comparison to climate modelling. In fact, they always get it wrong anyway. The computer models, for example, predict that there should be a hot spot or a warming spot above the tropics. This is the South Pole, this is the North, or towards the North. This is going up in the atmosphere. According to the models, that area should be warming because of the carbon dioxide absorbing all this energy. Again, check it against the measurements. Here is real measurements. There is no such warm spot. Doesn't exist. The models say something, reality says something different. The models are wrong. Oh, no, it's probably the data's wrong. This is what you get from the other side. Oh, no, the models are fine, it's the data that's wrong. Here's some model predictions. Quite a few of them. I always say, if in doubt, make smoke. As you can see, I mean, it's hopeless. Not even one model can match another. And they're basically going straight up. Reality doesn't seem to be wanting to do much to help them. Here, in a much more simplified form, is the prediction to 2030-ish or 2025. That's the red line of average of 102 model runs. This is the average of two satellite sets, and these are balloon data sets. Clearly, the two are diverging faster and faster. But you may say, oh, jolly good, look, they got those two dips right. Well, actually, they didn't. They were added manually because there were volcanoes, big ones, that produced a cooling effect. The computers, understandably, could not predict a volcanic eruption, so they added them by hand. So left alone, all you've got with the computers is a straight line moving up, saying CO2 and temperature will go together. And that cost us 100 million in Britain. Moving on. How do they do it? How do they fail so dismally? Well, they put a grid over the whole planet, and in the case of Britain, here's Britain, sorry, being patriotic here or whatever, pictures, and they put a 25-kilometre grid over everything. They've tried to reduce it now to 5 kilometres, but we'll go with this. And one, as it were, one data point, in effect, comes from each square. And they have to solve, for these squares, something called the Navier-Stokes equation. That's one version of it. Anybody like to just run me a quick solution? Yeah? It cannot be solved. It's an insoluble equation. You can put down what the factors are and relate them, but you cannot solve it. Even a computer cannot solve it. It has to smash it up guess certain parameters in order to make the thing work at all. For example, mu is viscosity of the gas, which if you made that naught, that rather complicated term would disappear. Well, that was helpful. The only difficulty was the models then told us that when you had mountains on planet Earth, the airspeed over the mountains broke the sound barrier, which was a little difficult to explain. They would miss things like thunderstorms anyway, because that could be within a 25-kilometre grid. If we tried to go to where you should be in order to solve that equation to get any meaningful answers, you have to go down to a 1 millimetre square to solve that same equation. Now, computers do crack at trying to solve it. How long would it take a computer to solve that equation for a 1 millimetre grid over the planet in order to project for the next 10 years of climate as to how it's going to change? How long would the best computers in the world take to do it? 10 to the power 20 years. To churn away, like deep thought, those of you who remember that, took 6 million years to work out the answer to life, the universe, and everything, being 42. These computers would take 10 to the power 20 years, which incidentally is a square of the age of the universe, to project just 10 years ahead. It's impossible. They're wasting their time. Time. Okay, I'll buzz on for a bit.
You're nearly up to your...
Right, okay, well, no need to clap yet. I haven't gone yet. I'll spin through one of the factors that we think, and I say think because there's evidence to support it, but like anything, like Einstein said, one experiment can prove you wrong, that one of the effects that's affecting global temperatures particularly, and it's from the stars of all strange places. We live in a spiral galaxy. We have a sun which is blasting out solar wind right out to the edge of the solar system. We are in effect in the sun's atmosphere, though we don't necessarily feel it like that. Deep in our galaxies, every now and again, there's a thing called a supernova, where a star explodes, and it sprays across the whole galaxy and beyond what are known as cosmic rays. They're not rays, they're atomic particles, mostly charged particles, protons, things like that, flying in all directions, and they don't go straight because they're charged. They get pulled in all sorts of directions. But basically, as a result, this whole solar system is having a drizzle of cosmic rays coming through the whole solar system, including us sitting here today. The effect of cosmic rays will be passing through your body as we speak. Which is a cheering thought, but you're still here. That's a supernova. Right, so here is our spiral galaxy. And as I said, it's these big exploding stars. Now, the effect of cosmic rays is interesting. If the solar wind, which is what the sun does, is strong, then it blows away quite a lot of the cosmic rays that are entering the solar system. It's like those sort of draft excluders in shops where they're blasting air down. The solar atmosphere is blowing it away. When the sun is strong and has a big solar wind, it has lots of sunspots. That's what those black dots are. When the sun goes weak, which it does, more cosmic rays impinge on the Earth and not blown away. This has an interesting effect. Cosmic rays, amongst many other things, as they come through the atmosphere, and I'm putting this simply, start the seeding of clouds. Start the seeding of clouds. Clouds don't always form when the water vapor in the atmosphere is sufficient for them to form. Because it's a supersaturated solution of water vapor, it needs a trigger. And cosmic rays are triggers for cloud formation. That is the theory. And as a result of cloud formation, when the clouds, as it is today, cover the areas of the Earth will cool. The net effect, particularly of this sort of cloud that we see out here, is cooling, average cooling globally. So when cosmic rays are strong, the Earth cools more than it would just because of this change in the sun's activity, which is small. Now, is there any evidence for this? Well, yes, there is. From 600 million years ago, we have passed in and out of spiral arms of our galaxy. When we're out between them, the amount of cosmic rays from the galaxy is reduced. Another factor that reduces it. When we're in amongst the stars, we actually have more cosmic rays, which is why a book was written called The Chilling Stars. This is the temperature change measured by proxy. This is the cosmic ray flux. And what is fascinating is that as the cosmic ray flux goes up, the temperature goes down. When it goes down, the temperature goes up, and so on. You've got this seesaw relationship. And that's over 600 million years. In the last 400 years, there was a period of very low activity in the sun in the middle of what we now call the Little Ice Age. Coincidence? I don't think so. Similarly, another minimum in the 1830s, 1820s, when there were frost fairs on the Thames and so forth. In the 1500s, for example, look at the skies. They're cloudy. They're like this. That's a winter scene. That's a harvest scene. Notice the sky. It's cloudy. During that period, people must have suffered from SAD in a big way, because the sun was seldom seen, which is why when Bruegel does his pictures, you seldom see a shadow, which is why his figures look rather odd. Not because they're badly painted, but no shadows, no shadows. And indeed, the cosmic ray flux measured by various proxies shows that it fits quite nicely in the medieval warm period when it was low, the Little Ice Age when it was high. So it looks like our climate is almost entirely beyond our human influence. The sun's variability and activity, which the IPCC ignore. The lunar orbit has an effect. The planetary orbits have an effect. There's a whole lot of stuff out there to look at. Our varying position in the solar system and in the galaxy has an effect. On Earth, the clouds and the ocean currents control the overall temperature, not the other way round, and they respond primarily to these extraterrestrial influences. I like a scripture here. He makes his clouds his chariot, and he walks upon the wings of the wind. He makes winds his messengers, and flaming fire his ministers, thinking of flaming fires of supernovae, causing our weather. It's astonishing to think that our weather has been caused by things going out there millions, if not billions of light years away, effectively affect the rain we have next Tuesday, or whatever it may be. Amazing. It's controlled from out there. We might be due for an next ice age. I'm just going to spin through. These are things I think we can go through. I want to put this up because from a theological point of view, I want to stress it. The earth was made for man, not man for the earth. The Greens tell us we must be obedient to the earth and do what it tells us, as if it can speak. From my perspective, God gave man the earth. He gave him dominion over the earth. It's a strong Hebrew word. We have a right, it's a gift to use. We may misuse it, I'm not denying that, but it remains a gift God gave to human beings. The one thing he didn't give man was control of the weather. If you read the scripture carefully, he does not. God controls the weather. The universe controls the weather. We don't, and we can't, except in tiny ways. Why has this all happened? Well, one of the key figures of the fall of the Berlin Wall. Why does this scare story emerge? The fall of the Berlin Wall suddenly there was a lack of fear of the Reds across the border. We needed a new fear. Human beings tend to thrive on fears. And very conveniently, the global warming scare became a substitute for the fear of the Reds. It also produces a gravy train. I better not be libelous and move hastily on. I'm going to move through that too. Fracking and so forth, good stuff. Somebody says, which you would prefer? Turbine country, which each turbine kills 600 birds a year, and goodness knows how many bats. Whereas a fracking country, all you have is a tap in a field. The things that wind farms can do, catch fire. I'm going to stop, yes, sorry. And of course, the whole energy issue, I will spin on from that. There we are. Yes, man. There we go. Right. I will stop at that point. Well, there's going to be a chance for questions afterwards, so.
Well, thank you very much indeed for that, Philip. Very enlightening. I thought I knew the subject, but you've raised a number of things that I wasn't aware of. I love your remark about Einstein, and one experiment would prove him wrong. I remember the story of when he arrived in America, and there was a great mob of journalists, and one of them said, Mr. Einstein, there are 100 physicists who disagree with your general theory of relativity. Indeed.
Yes,
and, well, you know the story. And he replied, if I were wrong, one would be enough, which I think is an excellent point. We've mentioned the hockey stick a number of times, and I must just give a quick plug for a book called The Hockey Stick Illusion by a guy called Montfort. A most extraordinary analysis of the way the story and the scandal emerged and the way the statistical manipulation of the data was taken apart by McIntyre and McKittrick, two guys who knew the statistics. I said earlier that climate science isn't just a single thing, it's lots of different things. Michael Mann may or may not be a good climatologist, but it becomes very evident that he certainly ain't a statistician. Now, what do we go on to next? I think I have the pleasure and opportunity of introducing Christian Gérondeau, who has the choice, by the way, of speaking either in English or in his native language of French. Very briefly, Christian is a French engineer with a distinguished career in engineering and was involved, I believe, in traffic management at the early stages of his career. Later, he became interested first in energy and then in the whole issue of climate change, and has published a number of books. As Philip has already said, Christian's book about the climate issue is available there for a small fee. The book contains a preface by Nigel Lawson, of course, Lord Lawson, former British Chancellor, and now the head of the Global Warming Policy Foundation. I mentioned earlier that I think my first attempt at a climate conference here was in 2008, and at that time we actually had Lord Lawson, who attended and spoke at that event. Wonderful man. He says that this is that Christian's book is a timely book. There are more and more reasons to question the conventional wisdom of what has become almost a religion. And I also rather liked the dedication at the beginning of Christian's book. This book is dedicated to the little Indian or African girl who will die because her mother had no choice but to cook on a domestic stove fueled by coal, wood, charcoal, or animal waste, the consequence of an immoral, baseless ideology. So Christian is going to tell us about some of the consequences of our energy policies, and I believe also has some words to say about President Trump and his approach to climate and energy. Christian, your choice, English or French?
Well, as I see, there are many English speaking people over here. I will try with English, but maybe I will refer to French from time to time. Okay. Thank you first for inviting me to this meeting. It's an opportunity to, first for me to know Philip, because we met in Paris 15 months ago during the Paris meeting, the famous meeting about climate, and I discovered today what you are saying. I was not aware, but in fact what I see is that we share most of the same points together, and I will try not to overlap what you have been saying, and maybe to stress different points. And speaking about energy and about economy of this climate problem. So let us begin maybe with one first graph, which is this. It's very small size, but I think you can see it anyway. If you can enlarge it, but if not, well, you see, it's very similar to one of your graphs. The evolution of the Earth's temperature over the last 20 years, but the difference with your graph is about the two last years. That's 215, 216. And you see this very high rise, which was due to what is well known under the name El Niño effect. It was a very strong El Niño effect, which summited about 1 year ago, between 215 and 216. But what is very interesting is that if you know if you look very closely, you see that we are now back to the level which we had before, which means that the El Niño is finished. It usually lasts for 1 year. It's what happened. This was a very strong one. And now we are entering what is called a La Niña effect, which is following El Niño, which means that this year, 2017, will be far cooler than the preceding years. So when you have, all of us, we have heard that year 2015 and year 2016 were beating the records. But we are sure that year 2017 will be far down, and what we are sure of course, is that we will not hear about that, because only the wrong, and I would say the staggering news are on the media. But I think this is very important to see that the decrease very sharp, which happened in year 2016, and no one, of course, report about this decrease. And we have the result month by month. The source is the IPCC official one. It's ACREC 4. Yeah. That's the acronym. It's coming from the Met, the Meteorological Office of Great Britain. And so it's the official record. And if you look at the overall evolution, I differ a little of what you are saying. You see a very small increase. And if you do the correlation, you see the rate of increase is the same as what it was for the last century, that's about 1 degree or even less than 1 degree per century. That's very important to remember, 1 degree per century, which has nothing to do, of course, with the official forecast. So that is the first interesting graph. The second one is, well, it's just a duplication of a graph which was published by a very important review, The Economist, last November. And this showed the evolution of temperature since year 1880 up to today. And when you look at that, and that kind of graph I have seen everywhere, you say, oh, it's absolutely awful. The Earth's temperature is increasing very sharply. This is just wrong, because what you don't realize is that the scales, the horizontal scale and the vertical scale, are just, I would say, ridiculous. The horizontal scale, you see, it's counting, it's more than 1 century. So you see the same scale for 1 century on the horizontal graph. And the same is on the vertical side is 1 degree. The change is by fraction of degrees. So when you put this on for many people, I'd say for all people, when they look at that, they say, oh, it's awful, it's increasing very rapidly. This is just because the scales are ridiculous. And also what you see on the very same graph is the right end of the graph. You see the El Niño I was speaking about going up, but you don't see the down side of it, which happened in year 2016. And at that time of when the graph was published, everyone knew about that, but they just forgot to show that it was going down in year 2016. And this is a usual way of showing things. And the title of the graph is, it's not reproduced because it's in French, it's Down Too Hot. That was the big title of the graph. It's just in The Economist, which is a reference publication the world over. And there were 3 pages after that explaining that the situation was awful. Now, what is the real situation? It's not at all this one. So we can go to the following graph. And this is very similar to your graph. Maybe you cannot see it very clearly, but it's the change in temperature, the same graph, in fact, from 1880 to today. And you see the average temperature of the Earth, the official sources, is going more or less between 13 degrees 0.7 and 14 degrees 0.7. So you see it's almost horizontal, and this is what we have been showing. And you see the prediction of IPCC on the right side of the graph. And you see it's absolutely, I wouldn't say impossible, because we can know exactly, but what the experience of the last century, even more than last century, shows is that the variations have been extremely limited. And that why would it suddenly increase very rapidly is, of course, an often question. And it's very funny to think that it just by showing to the politician people, excuse me, I have to stop this. It's by showing to the politician people and to the media the former graph that everyone is sure that the temperature of the Earth is rapidly increasing when it is not at all. So, okay, maybe we could now go to the other series of graphs, and maybe I will begin by speaking about the relation, yes, the relation between economy and energy. This is the evolution of the world consumption of energy. It's written in French, but I'm sure you can see that we had a very steep change in the middle of the last century, at the end of the war, in fact. Let us say year 1950. Since 1950, the consumption of energy by mankind has been multiplied by 6. And of this energy, 80% is provided by hydrocarbons. That's coal, that's fuel, the oil, and that's gas. So this is extremely important, because what we will see is that this increase in consumption of energy has resulted in an increase in the level of life of most, or not most, but a very large part of mankind, because production of goods and services is linked to the energy consumption. So this is a starting point. Maybe we will go to other, no, let us scrap this one. No, you just forget it. This is the emission of CO2. Of course, as energy is provided, 80% of it by hydrocarbon, CO2 emissions are increasing accordingly. It's a mathematical link. You cannot use hydrocarbons without producing CO2. And we don't know how to, let us say, get rid of CO2. There's no way. It's going in the atmosphere. So what you don't see maybe on this is the emission of CO2. What's very important is it's the yellow one increasing very rapidly. It's the China emission of CO2. And this is very important. China is the most populated country in the world, more than 1,300 million people. So, okay, this is just to see that the different parts of the world are producing more and more CO2, except for the developing world, the developed world, which is more or less level. What's important also is the lower part of the graph, because this is India. India is still producing far less CO2 than China, but this is going to change in the coming years, because India, as you know, will become the most populated country in the world in a few decades. Okay, so maybe we could go to the following graph. This is to show which emissions per person, and you'll see the huge differences between, on the left side of the graph, developed countries, the US, Canada, Australia, as far as I can see, which are producing more than 20 tons of CO2 per people. And on the right side, or the opposite, you will find India and Africa, where it's average 1 ton per people. So you go from 20 tons to 1 ton or even less for those who are not rich enough to use hydrocarbons. And let us say that developed countries, it's on average 10 tons, which is about the average in the European Union. But on the left side, you have big users, especially in North America. And on the right side, you have the developing countries. Some of them are very low. China is in the middle. China is around 6 tons, I think. We can find it, yes. And I'm sure, and this graph is maybe a bit old. I think it's still more than that today. China is not very far from a country like France. In France is about 6 tons out of China per people, and I think China is about the same today. So you see the huge discrepancy. But what you can see, of course, is that on the right side of the graph, you have developing countries which are going to increase their use of energy and, of course, hydrocarbons. So maybe we could go to the following graph, a graph which is extremely astonishing for those familiar with graph, is the relation between electricity production in China and gross national product in China. And you cannot distinguish both curves, which is very funny, is that you don't have to use different, what I would say, well, to explain it otherwise, you need only one explanation and one series of figures. Either you can you count the production in kilowatts, or the gross national product in dollars. By chance, you need only, on the right side of the picture, one series. It's exactly the same number. It just, you cannot believe that. And you see the two curves, you cannot distinguish them. So this is something very important. The wealth of countries is directly linked to the electricity production. It's not even parallel. You can you can have a direct relation between the two curves. And how is this electricity produced in China? It's produced more than 80% by coal-burning factories. So you have a direct relation between the use of hydrocarbons, coal, for that matter, and the wealth of the country. This is something which is, I think, extremely important. It's a universal, and it will be the same for India. The wealth of India will increase only if they have more electricity. And it's the same for Africa. And electricity, I will come back to that, can be produced in great quantities only with hydrocarbons, except for those countries who have hydroelectricity. But of course, this is a minority of countries which are able to produce electricity by hydroelectricity, by dams and rivers. Okay, so another figure, which one is it?
Next one.
Well, this is quite interesting also. This is, you could think it's the same curve, but it's not at all the same curve. It's a highways, motorways network in China. And you see that, in fact, China, there are two main, I would say, goals during the last decades. That was to provide electricity to their people, that explained the former curves, and also to provide them mobility. And for that, first of all, they built motorways. Now China is the first world producers of trucks, first world producers of cars. Of course, if they built this huge number of kilometers of motorways, it's not to have them being empty. Parallelly, they are producing cars and trucks. And the explanation of the increasing wealth of China is first they have electricity, but also they have motorways. And today, maybe you cannot read the figures on the side, on the right-hand side of the graph. It's more than 120,000 kilometers. In fact, it's increasing by 5,000 kilometers per year. And now if you look at the map of China, you will see that the country is crisscrossed, entirely crisscrossed by a network of motorways. Today they have more motorways than the United States, which is something which is almost unbelievable, because 30 years ago they had not 1 kilometer of motorway. So, but if you have motorways, that means, and cars and trucks, you are going to use fuel, oil, and of course you are going to produce CO2. So either for electricity or for transport, they have CO2 emissions which are very high. So maybe we could go to the next. Oh yes, that's important. That's very, very important. It's a comparison between China and India. And on the left side, you see you are 30 years ago, and it's a proportion of poor people in both countries, people living with less than $2 to US dollars purchasing power per day, less than $2 per day. And on the left side, you see that China figures are in green, India figures are in red. They were absolutely on the same level. 80 to 90% of the people, either in China or in India, were living with less than $2 per day. And now you see on the right side what happened. And you see the green line, that is for China. And now I have not the figures for the last years, but probably it's going to zero, which means that the poverty, as it is defined on an international level, has disappeared in China. And when you look at the red dots, which are for India, India is not at all on the level of China. And of course, India wants, the Indian people and the Indian managers, they want their country to suppress poverty, because the consequences of poverty are awful. But you see the difference between the two countries. And of course you understand why India is wanting to give electricity to its people, and also wanting to cover its countries with motorways, because these are the both sides of the story. So now we can maybe go to the next. And this is the life expectancy in China. Of course, as poverty is disappearing, life expectancy is increasing. By almost 10 years in about 10 years of average life span over the 3 last decades. I have not on these figures, on this draft, the figures for India, but it's far lower. India, the life expectancy, you see that the life expectancy in China is very close to the life expectancy of developed countries. In developed countries, it's around 80 years. Here we are at 76 years. The difference is very small. You have to remind that at the beginning of the 20th century, life expectancy in the developing world was around 25 years. Now, in China, we are at 76 years. Okay, maybe we can go to the following one. No, let us drop this one. Yes, this is very interesting. This you see the prognosis, the number of coal-producing units which are planned the world over. And the two big figures you see is for China and India. So China and India will build a huge number of coal electricity producing units in the coming, let us say, 15 years. The figure is about the same for India and for China. What is very interesting is the Chinese figure, because you may hear from places from time to time that China is moving to renewables for its production of electricity. They are presently building a number of renewables producing units, that's true, but they are not stopping at all to build coal producing units. So power plants, I mean coal power plants, and about the same level as India is forecasting. Okay, so, and of course other parts of the world also are planning to build coal power plants.
Next.
And so maybe we could go. Well, this is the number of coal power plants planned in India. You see, it's not a small amount. Because I will come back to that, the consequence of, or maybe I can say a few words. What is the consequence of the lack of electricity in a large part of the countries? The consequences are shown by the World Health Organization. And it's absolutely appalling. It's awful. What is happening is that 3 billion people are living in places where they make their cooking on open fires which are inside the living spaces. That means, and these open fires are with wood, with coal, or with animal dungs, I think, animal excrements. The result is that the toxicity of the air in these places is 400 times the equivalent of a place where people will be smoking cigarettes or cigars. 400 times more. And the consequences, as measured by WHO, is 4,300,000 deaths per year. It's the most important cause of deaths on Earth. 4,300,000 per year. Mainly women and children. Of course, because women and children are spending a large number of hours in their houses. I repeat, the toxicity of the air is 400 times what we know in places where people are smoking a lot. So it's absolutely awful. And maybe you notice that the World Health Organization issued a report 3 days ago about the number of people killed by air pollution that was in the newspapers almost all over. And they said that for the first time, the number of children killed by air pollution is more important than the number of children killed by diarrhea, which was the leading cause of death for children all over the world. More than 500,000 children are killed by air pollution. But what is absolutely surprising that when you see that, at least in the French media, everyone thought it was air pollution in the streets of the cities, because the WHO, they did not specify that it was not in the outside atmosphere, but it was in the inside atmosphere in those places where people are cooking on open fires. And I said, this is a lie. Because if they did not precise that, it was done on purpose to make people believe that it was air pollution in the atmosphere, outside atmosphere, which was dangerous, which is just wrong. Air pollution in the atmosphere, external atmosphere, is not really dangerous. If it was dangerous, the expectancy, the life expectancy in China would not be 76 years on average. And do you know what is the life expectancy either in Beijing or in Shanghai? It's more than 80 years, the average life expectancy, which is about the same that we have in France, in Brittany. And if you know Brittany in France, Bretagne, there are very few air pollution. We have about the same life expectancy in Brittany and in Shanghai or in Beijing, where we are told by WHO that air pollution is a very dangerous health problem. It's not very comfortable to have air pollution, but the figures are showing that it's not dangerous. Maybe the influence is marginal of life expectancy, on life expectancy, but obviously not very important, because they have about the same life expectancy as we have in developed countries, and even in Brittany, which is, as you may know, almost always very windy, with very pure air coming from the ocean. So this is just to show that this is a very important point. And why all these deaths? Because in the 3 billion people I'm speaking about, they don't have electricity. Of course, maybe they will not do they're cooking all of them on electric devices, but if they have electricity, they could reduce the open fire use and even suppress it. So it's what has been happening in China. In China, as you have seen, had the same poverty problem as India, but now they are in a far better situation. So this is, and how these countries can produce electricity is by having power plants, either with natural gas or with coal, or with oil, but very few of them are with oil. But it's either coal or natural gas, and they are producing CO2, even if using natural gas is producing half the quantity of CO2 that you have when you have coal, other main fuel. So there is a direct relation between the number of deaths on the Earth and the amount of electricity. And so this is one reason why CO2 is saving lives. It's a very direct link between both of them. We will speak about renewables and the dream of renewables maybe in the coming draft. I will see the coming figures. Well, because this is the production of electricity by renewables in Germany. What you see in red is photovoltaic production by solar panels. In green, it's by windmills. And what you see is that you cannot rely on these sources. Of course, electricity by photovoltaic panels is limited during daytime, because in nighttime you don't have solar electricity being produced. And even during daytime, it's changing a lot, with a peak around noon and very little at the sunset and during the morning. So you cannot rely on photovoltaic, even if, to be frank, we have to say that Germany is not the most favorable country to produce electricity with solar panels. In Africa, you have more production. On average, in Germany or in France, it's about the same. The production is 12% of what it would be if sun was shining 24 hours a day. 12 or 13%. In Africa, in southern countries, maybe you can go up to 20% or 25%, but that's all. And what do you do where there is no sunlight is a question. And the problem is the same with wind. It's over a week. You see that wind was blowing very efficiently at the beginning of the week. But if you know at the end of the week, there was almost no wind. No wind means no production of electricity. And of course, if you are thinking about Germany, you may know that they are closing their nuclear units, which is a big mistake, but they are building a lot of windmills with a lot of problems too, and solar panels. But you heard about Mercedes, Volkswagen, and Audi, and all these big car manufacturers. They have to work even if there is no sun or if there is no wind. So what are the Germans doing? They are building coal power plants to replace the nuclear plants, which shows the silliness, the absurdity of the renewable electricity, because it's electricity you cannot rely on, and we have no way to store electricity efficiently in large amounts. This is also one of the legends of the usual saying we hear about electricity is that someday we will be able to store electricity very cheaply and in huge quantities. This is just wrong. In a battery, in the same amount of battery, let us say in a kilo of battery, you can store 50 times less energy than in a kilo of oil. The ratio is 1 to 50. And even if you double the capacity of electrical batteries, the ratio will be 1 to 25. So that explains, for instance, that you heard, certainly you know about the Tesla cars, which are supposed to be the solution for the future, for car driving, for car movements. You have to know that they are able, the Tesla you can buy, I'm sure they are on sale in Brussels, or they are on sale in France, but most of them are sold in California to the billionaires of California because they are quite expensive. But with such a car you can drive 400 kilometers. 400 kilometers if the road is, I would say, level. If you go in mountain, it's not 400 kilometers. And not driving too rapidly. If you drive at very, I would say, decent speeds, but not very high speeds, you can drive 400 kilometers. That's nice. Do you know what the size of the battery in the car? It's 800 kilos. So with 800 kilos of battery, you can drive 400 kilometers. Well, I have a car. I'm off. My car is a diesel car. With, I don't know how many kilometers, I have to make the account, I could drive with 800 kilos of diesel. But what I know is that I can travel from the north to the south of France, more than 1,000 kilometers, with 50 liters of diesel. And you just have to compare the figures. And the result is that electric cars are on the market only because they are subsidized or because it's a fad. Some people like to spend their money, and it's their right. They are very happy. Usually, it's not their first car, of course. It's not even the second car. Usually, it's their third car. Because in the US, many homes, they have 3 cars or more. So it's the third car of American billionaires. That's very nice, but it's up to them. It's the same story. You can have a watch which is given almost for free, and you can spend huge amounts of money to have a watch. It's okay. But obviously, most of the people, they cannot buy very expensive watches. So if you want to have cars, and more people are having cars, it's not, the answer is not electricity. It's just a dream. Okay, so it's about the, oh, this is about the same story. You cannot see, but I will tell you what it is. It's the price of electricity in Europe. On the right side, you see 2 countries. This is Denmark and Germany, where electricity is awfully expensive. These are the 2 countries which have the most, the more important electricity producing unit with renewables. The more you have renewables, the more expensive is the cost of electricity. And this is very important for you because on the left side, you will see countries like Poland, where electricity is very cheap. And you understand why Poland doesn't believe in renewables, and they're opposed to all this absolutely silly story you have in the European Union about producing electricity with renewables. They don't want to pay their electricity the price that the Danish, which are set as an example, or the German are paying. Because that, what does that mean when you have very high prices of electricity? By the way, this is still less than the price you pay in Africa. In Africa, electricity is extremely expensive because there are very few power plants and the demand is important and the networks are very limited. So most of Africa, you have very little electricity and very expensive. But this is directly linked to poverty. When you have high prices of electricity, the poor people, even in Germany, have not enough money to pay for electricity. And if the other fuels are expensive, they don't have money to pay for gas or oil. What does that mean? That means that when it's cold, they cannot heat their homes. It's absolutely just incredible. But that is what is happening in Europe, in rich countries, due to the cost of electricity, the price of electricity, to be precise. So you see, again, a relation between poverty and the cost of energy. By the way, France is on the left side up to now, because, and this is an important point I will say a few words about. France is on the left side up to now, because we are still sillier and more absurd than the German, because we have electricity, 80% of our electricity is produced by nuclear plants, which means that without CO2 emissions, nuclear plants are not producing CO2. and we have decided to suppress them, or at least reduce their number, in favor of renewable energies, on which we cannot rely, as I explained, and which are extremely expensive. So we will suppress non-producing CO2 power plants and replace them by renewables non-producing CO2, which means that there is absolutely no reason, if you know that we are in overcapacity in France, due to the policy which was followed 30 years ago to create a large number of nuclear plants. We are in overcapacity, and we decide to suppress a large part of it and to replace them with renewables on which we cannot rely, which means that if we do that, we will have to build coal power plants and produce CO2. If you can understand the meaning of all this, you will tell me, but personally I was not able to do this. Okay? Okay, we cannot forget that. This is just to remind you that renewables are unpredictable. And this we come to a very important point. This is the fallacy of IPCC. I will stress this point maybe a bit. I have to explain, of course, what does that mean, this graph. On the left side, the far left side, we have the situation, the actual situation, and what is with a red circle on it is the number related to renewable energies in the world. So you see that it's 1.5% renewables energies. I'm not speaking of hydroelectricity, but wind and solar power plants are presently producing 1.5% of the energy used worldwide. Then the following figures is IPCC prediction for year 2030. And then you see that it would increase to, I cannot read the figure, but you see it, it's around probably 30%. 27%. But if you go to the following graph, you have now the prediction of the International Energy Agency for year 235. That means 5 years later. And you see it's around 2.5%. 3%. Yeah. So the official, and then you can go on the right-hand side. This is the prediction of IPCC for year 250. And then the prediction is that the world energy will be produced by renewables at a rate of, I think it's 63%. When, and of course, we don't have the prediction from International Energy Agency for this year, maybe it would be 5%. So you say, well, you cannot believe what you see. You have the official body in charge of energy, the International Energy Agency, which is an outfit, I don't know, what is the word, of OECD. Yeah. It's a subsidiary of OECD. They have more than 100 specialists. They know the projects of the different countries, country by country. And they say in year 2035, renewables will be able to produce 2.5%. Maybe it will be 4%, but that's the range. And IPCC say absolutely the opposite. It's very interesting because they produced a special report that was, I think, 5 years ago on renewable energy. That was called the Special Report on Renewable Energy, SRREN report. And in this report, they said we have the approval of more than 1,000 experts saying these figures, that in year 2050, they said close to 80% of the energy necessary for mankind will be produced by renewable, and on this 67% or something like that by wind and solar. And they said, we have the approval of more than 1,000 experts, and I can promise you, and they give the name of these experts, that no one of these experts would have signed the declaration of IPCC. No one. But they say, we have the approval, and on the report, you have the names. What happened? It's very interesting because in the same way, they act regarding the prediction of the temperature in the future. It's that they ask a number of, I would say, universities or whatever you want, to produce scenarios. And more than one, I think it's 140 scenarios were published coming from 140 different universities, research bodies all over the world. What do they put in these scenarios? Nobody knows. They put what they wanted. But nevertheless, almost all of these scenarios were not producing such silly predictions. Only one was with this prediction. And you have to know who produced the scenarios. It's the chief communication people for Greenpeace. It's just, and in my book, I give the name. You can check it. And who is paying this man? It's the solar industry. That's also official. It's official. So it's Greenpeace. It's the communication officer of Greenpeace, paid by the solar industry, who produced the only scenario which you find here, and this was the only scenario which was published and distributed by IPCC. And for the evolution of the future temperature in Earth, it was the same process. They asked for a huge number of scenarios, and they kept the only one which said at that time that the increase would be around 6 degrees by year 2100. So it's very clear. What is very interesting is that for the future temperature, you can always argue. You cannot argue about these figures because we know the International Energy Agency know the projects, the plans of India, China, and so on. And you can change this very rapidly. It's a long-term process. You need a number of years to build coal power plants or whatever. So we know with a great amount of certainty what will happen for the production of energy we need on Earth. And what we know is that even in year 2050, close to 80% of this energy will be provided by hydrocarbons and not by renewables. So I think this is a very important point because we have a body which contradicts IPCC. But what is absolutely sad, I would say, is that when you look at the reports of the International Energy Agency, you find the figures I show you, but you also find the title and the back of their annual report saying they approve the IPCC. So they contradict themselves in their annual report because you have the people who know the story, who are technician people. I will finish with this because it's a very important point. And you have the head people of the International Energy Agency, which are nominated by political ways, who don't know the topic. And in these reports, you have side by side the opinion of the technical people who know the story, but the overall managers who are saying exactly the opposite of what their own technical people are saying. And this is happening everywhere. This is happening within the World Bank, within the International Monetary Fund, and so on. You have at the head of these, I would say, political people or administrative people who are unable to understand the reality. And the people who know the reality, they have not access to the media and to the general opinion. And I will finish with that because this is a very important point. So when you, I'm speaking for France, but I'm afraid, with the exception of now the US and Russia, because neither Donald Trump or Vladimir Putin believe a single word of the global warming theory. Because both of them, they have listened to the real scientists, the people who are telling the truth. But the whole story, and it was a story you explained, it was I think it happened many times since Galileo and since what you said, I would say the story with Pasteur, who tried to explain exactly what you have been showing, that there was no spontaneous generation of microbes and so on. But the people who know the reality, they don't have access to the people who are taking the decisions, except maybe if you are taking the decisions. And the single fact that there are very few people here show that. What happened then? It's that the false scientists, the fake scientists, are taking the lead, because these people, they don't have doubts. They are sure of what they say. They were scientists. At the beginning, maybe they have been trained as scientists, but they are no longer scientists, because the real scientists, they have doubts. They want to know. They will not say, I'm sure. You will not find anyone among what I say, the real scientists, saying, I'm sure that in year 2100, the temperature of the Earth will not increase sharply. They will say there is very little probability, but they will not say, I'm sure. And that is not working with the political people and the media. With the political and the media, you have to be sure, which means you have not to be a scientist. So many people who are speaking about global warming are not scientists. They are knowledgeable in English or in French or in whatever you want, but they understand nothing. But what is terrible, and I know some people which are French engineers, which have the same scientist background, but who are no longer scientists because they have certainties. They are sure that the global warming will happen. And these are these people who are in touch with the political decision makers and with the media, because they are sure. And so this is, well, a sad aspect of the story, that you have these people who are the only one being listened to. And so what we could expect, and I finish with that, is that at least in France we will have new governments in a few months, even a few weeks from now. It's absolutely awful to see what all of them are saying about global warming, because if they were not going in the same direction, they would have no chance to be elected. So all of them, they are saying they believe in global warming and so on. But after we will have a new president, a new government, what we could try, but I don't know if we will be successful, is to have them listen to the real scientists. And of course, there are real scientists in the UK, in the US, and in France. But as long as they don't listen to the real scientists, there is no chance to move, really. Thank you very much.
Thank you, Christian, for those insights. And it's certainly the case that many of the scientists on the IPCC panel have expressed their disagreement with the conclusions of the IPCC. I know of one case where a particular scientist actually had to threaten legal action to get his name removed from a part of the report which he profoundly disagreed with.
It's German, in fact.
Good. Could we, can we now, do we have any questions from the floor? Yes, we have. Good.
Firstly, Philip, I have to do this. The fleet which took on the Spanish Armada was English, not British.
I beg his pardon.
You must never do that again. Much more seriously, you only at the very end moved on to what I was hoping to hear both of you comment on, which was whether Trump and the Trump incoming regime will make a difference. Because for the first time, we do seem to have an administration which is prepared to challenge these shibboleth, taboos, and other cultish approaches. And I wonder whether you think that offers a real hope that they'll start taking a more scientific and realistic approach.
Well, thank you very much indeed for that, Tony. And let me say, before I invite our speakers to respond, I mean, as far as I'm concerned, it is a dream come true. I have spent 10 years at least arguing this case, sometimes feeling I was a little bit of a lone voice, and suddenly we have the most powerful politician and national leader in the world who is taking this view. His first action that excited me was that he appointed my old friend Myron Ebell, who I've known for many years and is a committed climate skeptic, as the head of the transition team for the EPA. And he's now gone beyond that and appointed Scott Pruitt. I don't know Scott Pruitt, but what I hear about him is that he too is a committed climate skeptic. Indeed, he's noted for having brought many lawsuits against the EPA, and he is now populating the EPA with a bunch of Senator Imhoff's people and other very committed climate skeptics. So the world is changing. The problem for Europe is that America will become more and more competitive in energy as they continue to use coal, as they get more gas, as they get more oil. India and China, as I said in my opening remarks, will have cheap energy because, as we've heard, they're building coal-fired power stations like they're going out of style. Europe will become more and more isolated as a very high-cost, very uncompetitive, very unattractive place to invest. And that is something that I think all European politicians should worry about. Philip, do you want to come back on that?
Well, I mean, I think in a sense to add to, turn myself on, to add what Roger's been saying, I also know people like Tony Heller, who is actually the one who spotted the fraudulent activities with the temperature charts. He's also advising the Trump team. So, I mean, obviously it's early days. We know he has cut, or rather told NASA they are not to spend money on climate, inverted, so-called research anymore. So presumably he's cutting their funding in that regard. And I think NOAA, the whatever it is, the National, or whatever they call themselves, are also in trouble in that regard. And as you say, the EPA is being more or less turned on its head. I mean, it's the EPA that declared carbon dioxide was a poison gas. I mean, you know, it's like saying breast milk is junk food for babies. I mean, it's that stupid.
And can he use American financial contributory power to international organisations to begin to have an effect at the UN level and that kind of thing? Do you anticipate that I can put it no other way, will have the balls to cover this?
Yes.
Is that okay?
Christian?
It's on now.
Okay. Well, I will stress 2 points. First, probably the answer to a question we will have in a few weeks or in a few months. Because as far, but I'm sure that you are aware of that, as far as we understand, there is a discussion within the Trump administration to know if it's worthwhile to fight against the rest of the world on a topic which is no longer a problem for them. And even the Paris Agreement, as you know, decided nothing about CO2 because it was impossible. So it's an empty agreement is it worthwhile to fight the world over? I think this is a discussion they have. At the same time, they have Obamacare. They have to build a wall between Mexico and maybe Canada someday, and the US. Well, the second answer is probably to what you said, and it's about European Union. What you said is unfortunately very true, that we are killing ourselves or fighting. On se lance une balle dans le pied, sending a bullet in our foot. Okay. There is an argument which should be used, which is that European Union, as you rightly said, is producing 10%, let's say 10% of CO2 the world over. And those countries emitting the other 90%, who are they? Which are they? They are India, China, and Africa, and all the other countries, and now the US, because Donald Trump said we will do nothing to reduce our CO2 emissions. So what can expect European Union by acting on 10%, when 90%, this is something new. A few months ago, the Obama administration said we will fight CO2, but what's sure is sure that Trump said we will not fight CO2. So I feel this is a very strong argument. What can we do if we represent 10% and probably in a few years 5%? We can do nothing, because now the rest of the world, including the US, is saying that it will do nothing to reduce their emission. So I think, and when Trump said this in the effect, you see that even if you suppress entirely the emission by the European Union, maybe the level of CO2, which would have been in 2100, year 2100, will be 100 in year 2102. That's the only thing we can do, even if we suppress every emission.
We have lots more questions. So we'll try and move on. I think the system works better if you turn off the microphone when you're not using it. Yes, several. We've got three questions in a row coming. I would just conclude that discussion by saying what I'm looking for is Trump pulling America out of the Paris Agreement. The Paris Agreement's pretty meaningless anyway, but I think that will kill it. Aggers, you've asked for the floor.
Yes, thanks. I think, Philip, really just one of your slides told the whole story, and that was where the concentrations of CO2 are above the planet, all above the rainforest. That one thing just kills all the arguments, doesn't it? But a very quick question: why?
Tract.
Yeah, that's the one. Yeah. Why did suddenly the number of weather stations dramatically drop? That's the first question. And the second is, I want from either you or Roger, a quick... when I'm in schools, this question is always raised. All the other political people who are there say, oh, they trot the whole thing out. I come in with the other argument. They say, but 97%. I want a 100-word rebuttal from either of you. If you can't do it now, send it to me.
Can I just respond to the second point? Please read my blog. If you go to my blog, use the search engine, put 97% in, it's all there. Christopher Monkton's done a brilliant analysis. I mean, if the science behind global warming is a bit dodgy, the paper on which that 97% figure is just outrageous. Basically, what a couple of research students, they weren't particularly senior people, pulled together a whole load of papers, and they concluded that any scientific paper that didn't explicitly deny global warming supported it. And guess what they found? That is the answer. The answer on why the weather station numbers dropped, one of the main factors was the collapse of the Soviet Union. Soviet Union's a hell of a big place. It had lots and lots of weather stations. In the ensuing chaos, many of those were simply lost and ceased to report data.
And I think in addition to that, in fairness, at the early days, they were concerned that some weather stations, as was found in America, were in inappropriate places. And therefore, taking global temperatures based on weather stations is itself a hopeless enterprise, because you'd obviously say, well, you keep measuring in the same places globally, and that way we've got a consistent process. The trouble is you don't, because what was once a weather station sitting in somebody's farm is swamped by urban expansion, and the whole situation becomes different. So for a whole host of reasons, the whole business of these thermometer stations there are people who question, what does a global temperature mean? It doesn't mean anything much. It's just a notional figure. So, I mean, it's even questionable that a global temperature matters.
Could I just add one point to that?
Nobody has it.
And that is, of course, there are weather stations, which are one way of collecting the data. There are also satellites. The great thing about satellites is they cover the whole Earth on a fairly continuous and steady basis. And what is fascinating is that the main satellite records actually show less warming than the ground station records. And I think that's a significant factor as well. Now we have a gentleman sitting at the back who has a jolly good question for us.
Okay, Michael McMahon is the FDD. Thank you for your presentation, gentlemen. I'm very interested in the Christian aspect of this because it almost never comes up. You look, for example, at the Pope, who in September said it was a sin to destroy the environment. You look at Justin Welby, Archbishop of Canterbury, said the Church should be a key partner to fight climate change. We had the Noah movie, which was not written in the biblical phrase, it was written to look like Mother Nature getting her revenge back on us for pollution. There's also a quote-unquote Christian group called Operation Noah, who explicitly style themselves as a Christian response to climate change, and their main headline today says, looking at the big lies of people who, like ourselves, are a bit more sceptical. I'm very interested because the churches seem to be very, very aggressively in favour of this climate change issue. But it's rather tricky at times to criticise them for that because it makes you look sectarian, it makes you look like, you know, all the rest, and they do have some degree of moral authority. What I was curious about is how would we counter the churches and Christian organisations that are in favour of this without necessarily looking sectarian or like we've got a beef with the religion itself?
Great question, Michael. They used to call the Conservative Party, they used to call the Church of England the Conservative Party at prayer.
Yeah.
As I was saying to Philip last night, it seems now to have become the Liberal Democrats at prayer.
Yeah,
but
yeah.
As we have a vicar in our midst, I think we have to ask Philip to answer the question.
Well, part of it. I'm going to hand over to, because you've got some stuff to say as well. It's a very good question, and to some degree I do my tiny best churches do invite me occasionally to give talks from a Christian perspective. I wasn't being particularly Christian today, but I was touching on it. I think actually you're not going to the hierarchies aren't going to listen any more than the bureaucrats are going to listen. They're wedded to it to say we've got it wrong, which I would have thought is a Christian thing to do. I have made a mistake, I am sorry, is something that seems beyond them at the moment. I mean, we pray hard for the grace of God, anything can happen. But I think it's been like so many things. Actually, if you go to the people, in inverted commas, the people in the pew, the ordinary Christians who are bemused rather than, I mean, they're saying, why are the church rabbiting on about that? You know, as a Christian, you say, we have a gospel to proclaim. We have a Saviour to proclaim. Why are we wasting time on that? Exactly. I mean, in the sense, why am I wasting my time on it, I suppose? What I will say, this is not answering your question, is that being involved as I am in this area, I have found it an opportunity as a Christian to be able to speak about Christian matters to people I doubt I'd ever have done before. Including the brother of the current leader of the opposition, which is a great opportunity, who is a climate skeptic, I may stress. But, yeah, I mean, I'm not sure there's an answer to that, except to say work from the grassroots up, because that has worked in other areas, as we know. From a British point of view, I think Brexit was grassroots up, not politicians down.
We have not only a reverend, we also have a Christian who would like to comment on the issue.
Christian Gerald.
Well, I will speak as a Christian, even if I'm not a reverend. No. In fact, in my book, I have a whole chapter about the position of the Catholic Church on the matter. And it's absolutely, I think it's quite interesting, because the view of the present Pope was very well publicized by an encyclic dealing only with the topic of global warming. And it's almost a very good summary of the IPCC views. You have every point. Sea are increasing, flooding will become very more common, extreme events will be very frequent, species are disappearing, and all this is the responsibility of mankind. What is very interesting is that I have another paper described in my book saying about the opposite. And it's a Genesis which said that man is on the earth different from the other species, and that the other species and the vegetation are here to help man, to food him, and so on. What is very interesting is that the second paper is by Pope Benedict XVI. So you have the two popes, living popes, because Benedict XVI is still living, absolutely issuing opposite views, which is very satisfying. And you have to know, of course, that an encyclic is not the view of the Church. It is the view of the Pope himself. And to add to this topic, I quote in this same book a whole statement on the topic by Cardinal Pell. Cardinal Pell is an Australian, and he is a close advisor to the Pope on financial matters, not on global warming, obviously. Yeah. Because what he's saying is a very good analysis of what is happening. And he obviously is explaining that he is not believing one word of what, in fact, the Pope is saying. He's not saying it this way, but it's very clear. So the last point is that I heard a few days ago or a few weeks ago that the Pope was or would have said that the media are too pessimistic in their description of the world. So I wonder, maybe he talked with Cardinal Pell on global warming, because you cannot find a more pessimistic piece of communication than the encyclic of the Pope, which is absolutely dark, page after page. The world is awful, you have the capitalists killing the poor people and so on. So I just wonder, maybe diving light is coming to the Pope. That's an optimistic view, I recognize.
Thank you. Thank you very much, Christian. Now, gentleman with the beard there has a question.
That's me.
Oh, different beard.
Another beard.
Yeah, thank you for the floor. Maybe I missed the first part, so maybe this has been already addressed. I'm sorry if it has. I'm just wondering, because the president of the Maldives, he gave a few speeches already that his country is sinking, and I'm not a scientist, and I don't claim to be, but what is your take on this? And I hear that also they also have concrete plans to relocate the entire population away, given that their islands are basically sinking. So I was wondering, what's your take on this?
Well, can I respond first to that, and we'll go. Perhaps you weren't here when Philip actually produced the work of Niels Axel Morner, who has
he did the work on the Maldives.
He did the work on the Maldives particularly, but also around the Indian Ocean over a period, I think, of about 30 years. Well, very extended period.
Yeah,
let me just complete my point, if I may. He concluded, actually, that sea level around the Maldives had gone down over the 30-year period he had been studying it. Just let's get this in perspective. Sea level rose dramatically about 11,000, 12,000 years ago at the end of the last glaciation, and that was genuinely caused by massive ice melt. There were enormous ice fields across most of northern Europe, northern Russia, North America, and presumably in the south too. And when that ice melted, sea level rose rapidly. For example, Britain was joined on onto the continent. These were the days before Brexit. Britain was joined to the continent by a land bridge. Large areas of what is now the North Sea were actually exposed because sea level was so low. We can still find the remains of dwellings and settlements at what is now the bottom of the sea. Very rapid sea level rise, and the broad trend has been that sea level rise has continued, but that rise has got slower and slower and slower. The idea that sea level rise is accelerating is really a rather curious one. What we've also got, though, is poor countries, relatively poor or less developed countries, like the Maldives, island countries, who see the whole global warming story as a way of putting a guilt trip on the developed world and saying, you must give us more money. Let me put to you another point. If you go across the Pacific, all across the Pacific and in large parts of the Indian Ocean, there are atolls. Most of those atolls are about 5, 6, 7, 8 feet higher than sea level. Either you can theorize that 12,000 years ago, there were lots and lots of islands that were all 512 feet above sea level by some curious coincidence, and that then sea level rose and left them all just a few feet above sea level. Or you can go back and read one of Darwin's lesser-known papers where he realized that coral atolls actually respond to sea level and get higher if the sea level rises and drop if the sea level drops. Because the coral animal needs exposure to water, but also to be reasonably near the surface to survive. And the reason there are lots and lots of coral atolls all about the same size is because that's the way coral grows. Sorry, that was rather a long answer, but Philip.
I think, yeah, I mean, just to say that Niels Axel Munner, who did the official survey for the Maldives, for that president who had his thingamy underwater to 2009, as he said, the sea level looked as if it had dropped 30 centimetre, which is actually nearly a foot, it's a local effect, it's not a global effect. And a case of the problems that he faced is to do curiously with this stunted-looking tree, which is on the beach of one of the Maldive islands. And it's a useful marker if you're studying sea levels as to where the sea is coming up to vegetation, where you can see the marks on the shoreline and so on. And he looked at that and realized, well, if that's still, that's there and that hasn't moved in the last 50 years, it looks as if sea level has not made a lot of difference. However, he came back in 2003 and discovered it had gone. And he thought, oh, and I repeat this point, I have made a mistake. Now, that's a good scientist. He's come back. What he thought was his data looks as if it was mistaken. So he was thinking, well, right, I'm going to have to sort of go back to base until he found, literally, he went to a cafe to sit down and mentioned the tree. And they said, oh, didn't you know these Australian scientists came and pulled it down? So they put it back. I don't know if it'll grow. But in other words, people were concerned that his results were not consistent with the myth. And therefore, we must destroy the results. So it looks as if the myth is true. And just on the other issue, sea level measurement is extremely complicated because it's not just the sea levels rising, it's the shape of the sea basins that shift and change when you have earthquakes. Land itself is sinking or rising. England is tipping. Scotland is rising. The south of England is tipping, not by a lot, but it is happening, partly because at the end of the last ice age, when the glaciers were gone from Scotland, the land sprang back up. But as a consequence, the southern end started to tip down. So you will get local sea level rises, but you are measuring, you have to find a place where land is tipping. That's a good place to start work on. And Niels Axel is very good at that.
Could I just add, there's one example that is constantly raised by the alarmists, and that is that of Bangladesh.
And we know
Bangladesh is a lot of land there, farming land, residential land, is under threat from the sea. And people say, ha-ha, here we have evidence of sea level rise. If you go and talk to geologists who work with tectonic plates, you find that now, I'm not sure of the names of the plates, but basically the one that Bangladesh is on is slipping beneath the Burmese plate, and it is actually subsidence of the land, not raising the sea level. So I'm really emphasizing Philip's point that it's difficult to define sea level. It changes all the time with the tides. There are lots of local effects. There is a thermal expansion of water, and under it all there is tectonic plate movement with parts of the seabed rising and parts of the seabed and the associated land falling, and putting all those things together, it's a bit of a complicated mess.
Well, just a few words on this topic, because it's the reason why I've been involved in this matter of global warming. When I looked at the IPCC report, and I see that the sea level was increasing, this is the official figure, by 2 to 3 millimeters per year. And my reaction that there is a mistake, a printing mistake, because 2 or 3 millimeters per year, that means per decade, something like this. And when you read that whole country, the whole island will disappear, you just say, well, when there are waves during, I don't know, when the wind is blowing, you may have 6 meters or 10 meters high waves. What is the difference with 2 or 3 millimeters or centimeters? It was not a printing mistake. It's just absolutely silly. So in a century, it will be 20 to 30 centimeters. If this is true, this is official figures. You think that mankind could not cope with an increase from 20 to 30 centimeters in a century? This is just absolutely silly, but it shows that the people in charge are not aware of the proportion of what we call in French, les ordres de grandeur. They confound millimeters and meters, but one man who makes will make the difference, or will try not to make it, is Al Gore. In the film of Al Gore, An Inconvenient Truth, I think this is the right name. The increase in New York at the end of the century is not by 20 centimeters, which of those, or 30 centimeters, but by 6 meters. So it's just to show that these people, they are liars.
Yeah, I think that, yeah.
Good. Do we have any other? We have a question here. Yes.
Yes, Walter Simonson. I am really very much interested by the subject of climate since the conference you organized in 2008, which raised my interest about the subject, and I've read tons of books of the subject. But I would like to thank the speakers who developed a number of arguments that I already knew, but also a lot of things that I learned, new things that I learned. But one thing they did not mention, and that seems important to me, is the difference between the full scientific part of the assessment report of the IPCC, which is valuable work made by competent specialists, and the summary for the politicians that is saying very often exactly the opposite of the scientific part of the report. And there are valuable and renowned scientists like Judith Curry or Richard Lindzen, who were major contributors to the assessment report in the past, and who resigned from that organization and are very critical to the political the political pollution of what is now no longer science, but I rather say pseudoscience.
Thank you very much for that excellent question. You are absolutely right, of course. It's notorious that the summaries for policymakers that attach to the executive summaries, as you might say, that attach to the IPCC reports are notorious for being more alarmist and more certain than the actual text that they are summarising. And one of the problems there, of course, is governments need to justify themselves. The IPCC is a creature of governments. And therefore the summaries for policymakers are strongly influenced by national civil servants and politicians, and that is one of the outcomes. But Philip, do you want to add?
Well, I think Roger made the point. The Janet and Jill version, as we would say, is often in contradiction to what the papers deep down are saying. Most papers will often begin with a paragraph that nods to the, puts the pound of incense to the god of climate warming or whatever, but then gets on with their own topic, which probably has nothing to do with it or is not it. But you don't, I mean, it's the old thing too. You do not get your grants in scientific quarters now unless you are prepared first to put a pinch of incense on the god of the climate. I well remember, he's sadly dead now, Nigel Calder. Does that ring? He used to edit The New Scientist, and he died a year or so back, very sadly. But he, in an interview, said that if you wanted to do research, he put it, into the squirrels of Sussex, he said, well, if you would get your grant, if you say, I want to investigate the nut-gathering habits of squirrels in relation to climate change, but if you didn't put in that part, you wouldn't get your grant. So it's unfortunately, this whole area has become a self-sustaining thing. Talking of Richard Lindzen, I've got a lovely quote, or a couple of quotes, which he came up with when in front of the British Parliament in 2014. This lovely line, whatever the UK is doing about climate change will have no effect on your climate. It will have a profound effect on your economy. And it is clear that there is no policy that is better than doing nothing. I mean, he was wonderful at summarising things like that. And he also, actually, I remember later on that it was not Lord Deben, it was the other chap, Tim Yeo, was the chairman of the committee. And Lindzen sort of let slip the fact that quite a lot of climate scientists are not really in the first league of scientific endeavour. And Tim Yeo, well, are you telling me these people aren't, intelligent scientists? And Lindzen, who was very laid back, said, well, people who are really good at their subject, they go into astrophysics or physics or, something like that. And, the people who go into climate, they're not well, I didn't use the word sharp as knives in the drawer, but, they're not your top notch. And I remember Tim Yeo being very indignant. How dare he suggest such a thing? But, I think that's another problem. It's a complicated issue, because it's a religion.
Yes, I would just like to say that the situation is far worse than what you said. You have the report, you have the summary for policymakers, which no one can read. It's 60 pages, absolutely impossible to understand. That doesn't matter anyway. And then you have the declaration by the head of IPCC or by the General Secretary of the United Nations, which is a few phrases, but that's not the important matter. It's only one figure. And regarding the increase in the temperature, it was 6 degrees. And that's the only thing which got outside. It's not a summary of policy report for policymakers. And regarding the renewable energy, the figure was 80%. And it's the only thing which is going outside and which is going to the policymakers and the head of state. So this is just to go a little further than what you said. It's not a report for policymakers, it's the press release. And in the press release is the figure which will make headlines all over the world.
We live by sound bites and headlines. Actually, there's one thing that's come up. I was struck by Philip's quotation of the Lindzen comment, the best policy is to do nothing. Now, if we had Lord Lawson here, he might put it rather differently. He would say the best policy is not mitigation, which is trying to prevent warming happening, if you believe it's happening, but adaptation. In other words, wait and see whether any problems arise and respond appropriately. And if I may come back to the gentleman with the dark-coloured beard, as distinct from the gentleman with the pale beard, I didn't answer your specific point about shipping people out of the Maldives. But it will be much, much, much cheaper to relocate everybody from the Maldives to somewhere on higher ground than it would be to pursue the mitigation policies that we're pursuing at the moment. I think time is moving on. Have we got one last question, or can we wrap up there? Yes, sir.
This doesn't work.
Yeah.
Because the Defense Department of the United States in 2015, they said that climate change is the biggest threat to national security, to all of this. How do you square this? I mean, are they lying? Or?
Well, they're not lying. They're just buying into the groupthink. But when you start talking of biggest threats, you know, you get the Greens in here, and they all say climate change is the biggest threat to humanity. And then you say, OK, that's fine. Let's close down all our coal-fired power stations and build nuclear instead. And they say, no, nuclear is the biggest threat to humanity. I tell you what, I think militant Islam is the biggest threat to humanity. There are lots of biggest threats to humanity around the place. Can I thank our speakers? I've had a thoroughly enjoyable time listening to them. I hope you have too, and I thank you also very much for your questions. We may be a relatively small audience, but we are, of course, being web streamed. And I can tell you for sure that there are people out there watching our web stream, because you may have seen me rather rudely referring to Twitter, and I've got quite a lot of Twitter reaction. One of the people mentioned in Philip's presentation was Mr. Bob Ward.
Oh, yes.
Mr. Bob Ward.
Beloved
Mr. Bob Ward, if you're out there, thank you for watching.
Yep.
It was great. Thank you for your helpful comment. We really appreciate it. And may we thank our speakers in the traditional way.
Just to say, if anybody does want any of the literature, it's over there. I'm ready to take anybody's money. But most of the stuff is free. There's just the book that you have to pay for, isn't that right? So.